double think clouds your mind. If you walk that road, you'll be left behind, like swaying branches in the air, lost in confusion, filled with despair. Arguments and fallacies taken from the book of lies and deceit. There are those who will never see the gift of Logos that was given to me. And I know how water flows, and I know what level shows. You'll be wasting your time, trying to change what's been defined. I know what I know. I know what I know. You don't know what you don't know. Blackpool paradox. You think it's measuring, but it's not. It's optical phenomenon. All you fools think you know what's beyond. I know how water flows, and I know what level shows, and you'll be wasting your time, trying to change what's been defined. I know how water flows, and I know what level shows, and you'll be wasting your time trying to change what's been defined.
Horizon means the line where the sky meets the earth. Yeah, that's the definition I'm going by.
All horizontals are parallel to the plane of the horizon.
Let me finish. You can't just spout your logic at me. I'm still talking.
And we are live. Welcome everyone. It's Thursday. I mean, just I'm hoping to get rid of this professor. Well, this, you know, the first rebuttal video of Blue Marble Science and the mathematical chair of Utah Valley University in America. We should get over this with the last one. A few little updates to go over though. We had a visit from the guy at the end of that video there that said you can't just spout your logic at me. Guy called Dawn Shredder. You know, he's been around here quite a lot. They came round this morning, and then they decided to get like some sort of a pact where they were discussing whether they should make sock accounts to come over here to report the Discord server to try and get it shut down. That's the sort of people that they're dealing with. They were discussing it in a live stream thing in another Discord server. But it's there if you can go and if you want to go and see it. Unless the guys took it down, I've warned him that that there are people that are around this arena in different Discord servers that are actively conspiring to take down other Discord servers that they don't like. So obviously we've had to ban them so they don't come in, but they're still trying to make packs and plans to make new accounts so they can come in here to report the server to take it down. So if you're wondering, what sort of an arena we're in, there you go. That's what we're doing. That's Dawn Shredder and another guy. I don't know what the other one was called. Anyone remember? Just in case. It's something, something. Strange people, completely model obsessed. They won't take it. Tis life. I think they might be those flat earth weirdos. But you can never tell. Right, let me get this. We're going to go over this video, but I think it's a good idea to go over the video that we are going over first. Let me get it for you guys in Discord. Alright. And there you go for you guys. That's a bit better. Right, so this is the video that we were initially going over. Just to point out the original. Okay, so let's go over this. This is what this man said in the video we initially went over. That these guys are reporting.
So in this series, I'm exposing all the lies that math teachers have ever told you. And boy, do they tell a lot.
Right, so all the lies that math teachers tell you, and they tell a lot.
Well, okay, not really, but math teachers do tend to leave things.
Not really. So was it a lie? Like, not really? Do teachers tell a lot of lies? Or not a lot of lies? Just some lies? And what
well, you
does
can't
his
tell now,
not
can you?
really mean? Yeah, it's a bit...
Yeah, you can't tell, right? So there's not, I'd say he's not being on the level, shall we say?
Yeah. Yeah, there's some sort of... There's a certain level of deceit going on within what he's just said. But we'll carry on. This is what we're talking about here.
Things out that are too complicated to get at the point that you're trying to say. The lie that I want to talk to you about today is the angle sum of a triangle.
The lie that he wants to talk about today. Again, reinforcing this fact that there's a lie. That he said, well, not really, but this is a lie because he's just told you again.
The lie that I want to talk to you about today is the angle sum of a triangle. Now, you probably know from your geometry classes that...
He uses the term know. You probably know from your geometry classes
that if you take the three angles in a triangle and you add up the measures of each of those three angles, if you do it in degrees, you should get 180 degrees. If you add them up in radians, you should get pi, which is the best number, by the way. But it actually turns out that that fact depends upon the geometry that you're in, and it's only true if you're in a flat space.
How can it be true at all? He says it's only true if you're in a flat space, whatever that means. We can get to that in a second. But just going back to the context of the lie, he said that's the context. The lie that you've been told is that triangles have 180 degrees.
Yeah.
But then he says it's only true. How can a lie be true at the same time?
Yeah.
A lie, something could be a lie and truth at the same time. That should tell you everything you need to know, I think, about this particular gentleman here.
Mm-hmm. A mathematical chair of Utah Valley University. And he says it's only true in a flat space. Well, do we not live in a place where you know that triangles have 180 degrees? So the question I would ask, do we live in flat space according to this mathematical professor? Because triangles have 180 degrees in reality. So would that him be saying that somehow we live in a flat space?
I think it would have to, given what he just said, right?
Yeah. So again, these are some of the questions that we would like to ask this man. Now, he's gone over to Blue Marble Sciences. Blue Marble has cut the video and edited it and put little quippy remarks on it as we're going over it. But he doesn't seem to have addressed this. Like whether we actually live in this space where triangles have 180 degrees. Because we know that, you know, there have been mathematicians in the past that have also said these things. Descartes, for one, with Cartesian space, X, Y, Z, Cartesian coordinate system that we go off. I mean, he said that if you can measure a triangle with 180 degrees, then that's the space that you're in. You know what space you're in by measuring the angles within a triangle. And since in reality we know that there's a proof of triangles having 180 degrees, you would conclude that the space that we live in is the space that accommodates triangles having 180 degrees. So that's what I'm trying to... the whole point of us going over this video is this first 1 minute that this man goes over within this video that we went over.
And according to this man, that space is, again, what? It's flat space? That's what he said?
Yeah, that's what he said. It's only
According to
true
this
in flat
particular
space.
person,
Yeah.
flat space. So we live in flat space. We can say that because we know,
We
and he
can
said,
deduce that
you
from
know,
what this man says.
yeah. Well, he said it himself, right? You know that triangles have 180 degrees, right?
Yeah.
He didn't say you've been told the lie, although he did intimate that at the beginning. So again, it's kind of speaking with forked tongue, maybe a little bit. I don't know, but he certainly landed on flat space. If it's only true if that triangles have 180 degrees, if we live in a flat space. So clearly, we must live in a flat space, according to this gentleman.
Yeah.
I don't know what that means.
No, it doesn't make any sense. It just sounds
Maybe
like
someone
a
else
nonsense, doesn't it? It sounds more globe-like than anything. But I mean, if that's what this mathematician's saying, then, well, he did say that he doesn't do much teaching nowadays. He just, you know, does emails and stuff like that, having a higher position.
Maybe
Right.
a bit of research.
Yeah, so I just wanted everybody to know the lie that we initially started this video with, just before we get to the end part of Blue Marble Science and this man going over it, right? The last 45 minutes. So.
And
Right, so here's we go. This is from last night. This is the final part of this video. Remember the lie. And nobody's seen any of this other geometry because we're just dealing with Euclidean. Like he said, pi or pi angles, and he's got it in his equation here. He's got pi. So that's where flat space, according to this man, these calculations that he's doing are taking place within where the angles of a triangle have pi radians, let's say. Within his own mathematics. So let's go. We'll catch up. I'll put it back on a little bit. I don't want to go too much further back. a few seconds.
You know, they were talking earlier in this video about the idea that there are so many proofs of like the Pythagorean theorem, or so many proofs that the angle sum of a triangle is 180 degrees. How do they think they prove these things? Like you know, like
Pythagorean theorem is mainly geometrical, but there are some other ways of proving it. But there, within mathematics, the Pythagorean theorem has the most proofs, different proofs, because it's one of those things that's true. So when things are true, they have proofs to go along with them. Now, there are obviously multiple ways to derive at that truth, because it's a truth, i.e. that there are many proofs for you to end up at something that is self-evident, really. But the point of this is that there are proofs that go along with these things that are true.
have they ever read one of these things? Like, do they think that algebra never comes into play in a proof ever? I mean, it is fair, it doesn't always, but there's tons of stuff in geometry that are described through algebraic formulas. And it's the idea that you can't move to algebra in talking about a geometric proof is so far removed from how anybody does this stuff. Like, algebra is a tool that can be used to understand things. And that's what we're doing here. Like, there's no magic. This is purely algebra. Yes. It only feels like magic because they don't understand it. Like that line, any sufficiently advanced society looks like magic, right?
Yeah.
Like any sufficiently sophisticated mathematical argument looks like magic to somebody who doesn't understand it, I guess.
I guess.
Wow, they're doing a lot of guessing. Both of them are guessing. We understand
you
a
might
squared plus b squared equals c squared. That's not hard to understand. It's only because you understand the proof that goes along with it involving the squares.
And you would think that, well, at least I would think anyway, that it might be beneficial then if that's what he thinks about, you know, the discussion that we had around his video. Maybe he would want to come by and have a chat about those things. Find out if we are you know, completely clueless on these types of things, rather than making an assumption, which I think he's doing by virtue of what we discussed about his video.
Mm-hmm.
Come on over and have a conversation, Scholar Sauce.
Yeah, I'd love to have a chat. Probe the mathematical mind. Exactly the same. There doesn't seem to be a link somewhere between him adding pi into this equation. Right now, pi is a relationship of the circle to the diameter. Well, he's got the radius here as well.
Bill, pi came from the area of a sphere. How did you miss it?
Pi came from the area of a sphere. Really? Blue? It's got it wrote out on the screen as well. Pi came from the area of a sphere. It's really weird, that. Comes from a ratio of the diameter and the circumference. And now it comes from an area of a sphere.
Is the area of a sphere C over D?
It means the surface area of the sphere, but we'll give him a break, right? Because he is writing his quippy comments. 4 pi r squared was what he was doing, where it came from in his little formula, but that's not where pi comes from. But hey, it's all right. It's just blue marble science.
That's how pi got back in this equation.
It is quite interesting, actually. You know, if you want to do it from
It would be a good time for Blue Marble to come out and say about spherical pi, right? Because I mean, this video's been completely open for Blue to point out that he is the aforementioned expert on spherical pi. Try Googling it. Won't be long before you find out Blue Marble and his videos.
Bev's point of view. He is right that pi is the ratio of a circumference to the diameter of a circle.
Yeah.
Whoa.
Wow, that's a relief.
Blue's got it wrote here. Pi came from the area of the sphere, Bev. But turns out Bev was right about where pi comes from. That must mean that Blue Marble's wrong.
I'm relieved.
Yeah.
It also turns out to be the ratio of the surface area of a sphere to the diameter of that sphere.
Ooh. Really?
But the diameter is equal to 2r, 2 radiuses, right? And if you
Right.
square 2r, you get 4r squared. That's where the 4r came from. So the pi here is here simply because it actually is the ratio between the surface area of the sphere and its diameter.
Wow. Now it's the ratio between the surface area of the sphere and the diameter. Pi. So not only is it the ratio of the diameter to the circumference, but like he says in this, it's also the ratio of the diameter to the surface area of the sphere. Same thing. Same number. Just different ratios. That works, right, everyone? You think that does that compute? Same ratio. Go back over it. Let's listen to what he says again, just to make sure.
Squared. That's where the 4r came from. So the pi here is here simply because it actually is the ratio between the surface area of the sphere and its diameter.
Yeah. Yeah, ratio of the circumference to the diameter. And he's talking about the same diameter, except this pi is a ratio of the surface area to the diameter. I notice everybody's gone quiet because it doesn't seem to make any sense, does it? How could it be the same ratio and the same pi, but a ratio to different things? One of them being the diameter, which is the same. Doesn't seem to make any sense. Why he even said that? But I bet he's talking mathematically within his algebraic function, the way he breaks it down. But it literally doesn't make any sense geometrically, logically.
It is contradiction.
Mm-hmm. But this is new modern maths, obviously.
And he's violating law of identity because this ratio is fixed and it is between a diameter and circumference. So even if he's talking about this area of the sphere, in fact, he's talking about ratio between diameter of the sphere, which is inside of the sphere, and the great circle. That would be right, but it is still a ratio between straight line diameter and circumference.
Yeah, he
which
doesn't
is
say
a
that
circle.
though, does he? He says it's the surface area and the diameter, which is
Sorry,
nonsense.
it is nonsense because diameter has length and area is squared. It is in two directions, so we have length and breadth. So it cannot be. It is just not. Yes, it is nonsense, contradiction, and violating law of identity. So at the same time. So because he said that you are right, and then he says he is trying to to say that you are right and blue is right. It cannot be. No, it cannot be.
Diletheism. I've been talking to him in the chat earlier today. This, to me, is diletheism showing its way. It's being introduced into new modern mathematics.
And by the way, talking about this, what is on the screen, pi came from the area of the sphere. No, it is not, because pi is antecedent. We are using pi to calculate area. Therefore, it is a necessary antecedent. And in conclusion, we have area. And antecedent cannot be conclusion. So he's just illogical. This statement is illogical.
It's like backwards, isn't it? He thinks it comes from the consequent, right? The sphere area is made from us knowing that pi's there, but he's deriving it backwards.
Yes, it is circular reasoning, because if pi came from the area of the sphere, and it is used also to calculate the area, it is circular reasoning. So it cannot be true. Nonsense, complete nonsense.
I agree.
We just changed to talking about radii, and that's where the 4 pi came from. So the pi is coming here completely geometrically, and just happens to be the same number that's the ratio between a circumference and diameter. That same number is also the ratio from the surface area to the diameter squared. And that's literally why it's in this equation. So it's completely geometrical why pi is here.
The diameter squared? Now,
I think that it was a radius squared, not diameter.
Good luck getting him to see that.
Yeah, I know, right?
there's pi. So does he have the diameter and the radius? Or has that got the radius square with the diameter and the circumference and the ratio of these two together?
I think I'll just refer to my previous comment.
Yeah. It's a constant, Bev. It's just a constant. That's all. We just
a constant? How can he keep saying that? Blue's got spherical pi. How can it be a constant? Why is he not bothered telling this guy? I think he's a bit shy, right? He doesn't want to, he doesn't want to tell this guy that he's made this spherical pi breakthrough.
Yes, and by the way, it is not about number, because this pi is constant only because it is a ratio. This is the let's say, the reason why pi is constant, because it is fixed ratio between two fixed things. So it is diameter and circumference in that the same circle. So if you change diameter and therefore you are changing circumference, the ratio will be the same. So it has to be ratio, because without that two things, circumference and diameter, it is not a constant. You can change diameter. Diameter itself is not constant, and circumference itself is not constant. But ratio between them is constant. So that's it.
Yeah, we do understand this, but Blue and this man here, like, if only Scholar Sourced, this lecturer or ex-lecturer, he just does emails now. If he wants to come over and talk, then I don't think he'll be left in as much confusion, because we can clarify these things. and he'll be able to clarify those things to us as well. It's very strange that he's going through this blue marble science go-between, because everybody knows that blue marble science has got a problem with the on the level server for some reason. It's his blue marble science, I'm pretty sure, that does that. So he's slightly biased, and also the other people that are advising this university lecturer. I'd advise him slightly differently, but I mean, that's only if he can come over and have a chat, which I hope he does.
Give it a name. That's all.
Never fit with me either, because I couldn't make it work. It doesn't seem logical. It doesn't make any sense why you should be able to just say, well, the circle is pi, but pi is the relationship of the circumference to the radius, the circumference to the diameter. But then you should say pi r squared. 5 minutes left. It's going to get technical now because he's already pulled out the algebra.
Well, if you actually made a triangle, then that triangle's area is necessarily positive. Well, r squared is positive because that's the radius of the sphere. So the only possible way for the product on the left-hand side, the angle sum minus pi times the r squared, the only way for that to be positive is if the angle sum minus pi is also strictly positive. Well, this...
And that's the crux of the entire argument right there.
Right, exactly.
That's exactly
So
what
first
you were
off,
getting to.
It has to be greater. It has to be greater because they put this little sign here.
If this was a Euclidean triangle in Euclidean space, this doesn't work.
well, yeah, this formula wouldn't be true for that triangle. That's for sure.
Yeah.
The crux of the argument here is that sigma minus pi times r squared equals the area of that region of the sphere, which we're calling that triangle, right? That's what a spherical triangle is, or a triangle on the sphere. That equation, we've proven that equation is true geometrically.
Yep.
That area is equal to that thing there. Well, if one side of an equality is greater than 0, the other side of that equality has to also be greater than 0. So because the area of our triangle is necessarily positive because it's an actual area, and area is not negative, and it's certainly, you know, in this case, we're making it large enough that it's not 0 either, right? So this area is strictly positive, then the other side of that equation also has to be strictly positive. Well, you have the product of two numbers that have to be strictly positive. The r squared is one of the numbers, sigma minus pi is the other number. R squared is the square of a non-negative, is the square of a non-zero number. It's specifically a non-negative number because, as I said in the video, it's the radius. If you square a non-zero number, you get a strictly positive number. So you have a product here of two numbers, and you know the product has to be strictly greater than 0, and they're going to complain about the word strictly. That just means it's not equal to 0. So it's greater than, not greater than, or equal to. That's what strictly greater than means.
Yeah.
But so this product is greater than 0, and one of the factors of the two numbers that are being multiplied together is also greater than 0. Well, what's the only way to multiply two numbers together and get a positive number? You have to have the same sign. And if one of the numbers is positive, that means the other number has to also be positive. That's literally the logic that's here. So, you know, he's complaining about it not being logical. I'm using logical rules about how real numbers work in order to make this next statement here. So that is purely logical based off of how real numbers work.
But he's using pi and...
Yeah, so I have some, let's say, objection, because what is sigma? Sigma is it is sum of three angles, and pi it is here. It is I assume 180 degrees. So because you cannot subtract linear distance, which is pi, from an angle, because it is nonsense. So this pi here has to be an angle, which is strange, but okay. And this angle, I assume, is 180 degrees.
Yeah, it's pi radians, isn't it? The amount of radiuses that make up what they call pi. So that's 3.14 lengths of the radius within this. So he's, you know, they're trying to equate an angle to a line, a distance. It's sort of one of the things that we did with Ruhif, or Ruhif tried to do early on, was try to relate the opposite side to the angle and relate that as a distance. Ruhif did it by putting a ruler on a picture. You saw Ranty do it in the opening thing to this very thing today.
But still,
Opposite
question
side
is, question is that this sigma, which is sum of three angles, and this theta 1, theta 2, and theta 3. And as I remember, he started from the center of the sphere, and they are these angles are to the tangent of the sphere, as I remember. So they are right angles, 90 degrees, and it would be more because three right angles, but it is not about triangle here. So I don't know how he's creating this spherical triangle here. And he's proving that it has to be greater than 180 degrees. These three angles are not creating triangle in his picture before. So why he's somehow proving, because this T, this is spherical triangle. So it is not derivation from what he said before, because he just had three planes made of great circles, and they are of course perpendicular to each other, so of course they have 90 degrees, but it has nothing to do with triangle. So I don't know why, because in this equation, he is trying to prove that the spherical triangle, which is not triangle, has to have more than 180 degrees, because sigma minus pi is still positive. It means greater, because pi is 180 degrees, so it has to be greater than 0. But it is sum of these. What is sigma? It is not about triangle. So why he's trying to prove something with triangle which was not taken from triangle, but just perpendicular planes? I don't get it. How he thinks that it would prove anything with spherical triangles. For me, it is just non sequitur. This is how I understand this, let's say, not logic thinking. Because I would like to hear explanation why this sigma, three angles, are now angles of triangle.
Yeah, I think Blue Marble Science is in the chat offering a bit of advice. Just click the link, Blue, pop on in if you want to give us some help and like answer this question that Paper's asking.
Yes, I am asking this question. Why three, this sigma, they are three angles, and they are originally not angles of any triangle. And now they are. magically. So I need explanation how they turned into angles of triangle.
Yeah, well, pi being 180 degrees as he's relating to it here, that is a Euclidean triangle. So he's relating something supposedly that is non-Euclidean to pi, the relationship of 180 degrees, like he said, that is Euclidean. The planar triangle has 180 degrees, and he's relating this one. He's minusing one from the other, which is fantastic, really, isn't it?
Yes, but if this sigma is theta 1, theta 2, and theta 3, and these three angles are angles of spherical triangle, it is not in his description. This is my objection. It is not in his description. So it means that, and if it is, they are spherical angles of a spherical triangle. So he's creating circular reasoning again, because you cannot prove that if you subtract from spherical triangle normal triangle angles, that would be positive. Yes, but still, it is just speculation. It is not proving anything. So I don't know why he's doing that. So I have two questions, in fact. Why he's making circular reasoning, and how he has these three angles being now angles of spherical triangle. They were not originally. So
no, they were just angles between the planes, the
between the planes,
great circle planes, let's say.
Yeah, so that would be maybe his magic trick. I don't know, but still, it is non sequitur.
Yeah, I'd like to know as well. I mean, Lakota's putting out there that Blues offered Scholasaurus up as a sacrificial lamb. It seems like that to me, because he's talking about Euclidean stuff here. And you've not mentioned your spherical pi once, Blue. Never. Why's that? Why are you allowing this man to continue on with his Euclidean stuff when you know that you've got a video titled Spherical Pi?
By the way, what Blue is writing here? Yes, we saw beginning of the video, and these angles are angles between planes, internal, let's say, planes in sphere, inside of the sphere. So they are not angles of spherical triangle at all, because he assigned them before talking about spherical triangle. I need an explanation.
If you do want to pop in, Blue, just whenever you feel like it. You've offered the help, and papers saying, yeah, there are some things that would be good for you to come and help us out with as to why the reasoning seems to have broken down. But, we'll carry on doing that. If you can muster yourself up to click that button and come over for a chat, bring Alan over with you. Unless he's busy. Taking logical conclusions derived from what necessary.
Yes, but he's talking about this triangle, and this is not a triangle. He's just subtracting some area from the surface of the ball. He calls it triangle, and he's trying to prove that that he is like calculating angles in this triangle, I think. But
now pause it there, because he makes an interesting point. Now, You could argue that there's an element of semantics here. If you argue that the word triangle only ever refers to Euclidean triangle, then what I think his name is Paper, is that what you said his name was?
Yeah.
So if you make that claim that a triangle only refers to a Euclidean triangle, then he's right. Like this
There you
statement's
go.
still true, but it's just referring to that region on the sphere that we are highlighting.
There you go. A bit of honesty.
Yeah.
At
semantics,
last.
yeah.
Well done. Well done, that man.
And that region has this property. But mathematicians use the word triangle to refer to anything in any geometry that's formed by what we call lines, which are the things that are the shortest that give you the shortest distance between 2 points. I mean, I'm being
The shortest
Oh,
distance
so-
between 2
So
points.
it is based on assumption. And this assumption is illogical because he is now saying that whatever mathematician assume to be a straight line, Euclidean or spherical straight line,
The shortest distance between 2 points, though, he's saying. He's feeding into Bob's modus ponens here. The shortest distance between 2
Yeah.
points. Because the
Yeah,
shortest
but-
distance between 2 points in reality is a straight line.
yes, and it cannot be on the surface of the sphere. So he is refuting himself because he is saying that we can have normal triangle, Euclidean triangle, and spherical triangle because on the surface of the sphere we have different straight line. This is what he is saying, and but it is impossible. You cannot have straight line being different, diverse straight line.
Yeah.
No, there's only
And
one
and
kind
if
of straight line.
mathematicians aren't that good that they can decide what a straight line's going to be. Like, mathematicians don't have that superpower.
Yeah, I agree. Yeah, they have to stick to definition,
Yeah.
given definition.
being a little loosey goosey. Really, it has to do with the straightest possible path that I was talking about, those derivatives and stuff.
Right.
But
Did he say loosey goosey? Is that a mathematical term?
No,
Go back
I
over
even
that.
don't know what
Let's-
does
let's-
it mean.
Yeah, let's go back and listen to it. Well, exactly what he says. 20 seconds.
But mathematicians use the word triangle to refer to anything in any geometry that's formed by what we call lines, which are the things that are the shortest that give you the shortest distance between 2 points. I mean, I'm being a little loosey goosey. Really, it has to do with the straightest possible path that I was talking about, those derivatives and stuff.
Perhaps loosey goosey is one of those lies that teachers say, and it's a bit hard to tell, like, what he means. Bit of a magic trick. I don't think I've ever heard of loosey goosey as a mathematical term before.
But to be simplistic, it's the shortest distance between 2 points. That's what a geodesic is. Whenever you talk about triangles in any geometric context, you're talking about drawing it with those kinds of segments. So a spherical triangle is as much a triangle as a Euclidean one is. The only difference between the two places is the context. The sides of that.
The context. The only difference is the
No.
context. Well, no, because it's defined within one and doesn't seem to be defined anywhere else. Just imagined.
Yes, and you have 3 points. So you create triangle and a plane at the same time because you connect 3 points with straight lines. Because if you connect them with curved lines, you will not have a plane. So this is for me, it is so easy that you cannot connect these 3 points with any line, just curved line, because you have your goal or your outcome is triangle. It means planar figure. if you are connecting these 3 points with curved line, you will not have planar figure. And triangle is planar figure. So,
Yep.
Triangle and a sphere are the straightest possible paths that you can have on a sphere, just like the lines in a Euclidean plane are the
sorry,
straightest possible.
can you pause?
Yep.
This is what I call soletism. You will call it pleonasm. Shortest possible. No, not shortest possible, or possibly shortest. No, just shortest. He's adding a redundant word to create something in between, impossible and has to be. That's why he's talking about possibly shortest distance. No, geometry is not about possibility, and this possibility is taken from circumstances, because surface of the sphere is circumstantial. It's not general situation. And when we are establishing axioms or definitions, we are not referring to circumstances. And he is referring to circumstances on the surface of the sphere. It is shortest possible distance. No, you cannot create definition in that manner, because you are creating definition in general. So definition describes thing without any circumstantial circumstances, let's say. Without any circumstances. It just is as it is always. Not on the surface of the sphere, it will be something else. You cannot do that. So this is all bunk for me, what he's saying. This possible shortest distance. And this is sophistry.
Yeah.
Possible lines that you can have there. They're the lines that don't turn or move only with the geometry of the space. So like the spherical triangle is every bit as much a triangle in every precise sense of that word. It's a triangle as much as the other one is. There's no reason to make a distinction there other than you want to arbitrarily emphasize that Euclidean is all you want to talk about. But that's a pretty naive way to look at it, since there's tons of other geometries that exist.
Tons of other geometries that exist.
Well, and he said something I would say really stupid, because he said that they are essentially the same. This is what he said.
Yeah.
So triangle in which we have only 180 degrees, no more, no less, is the same triangle in which we can have more or less, because it depends on geometry. But let's say in spherical geometry, you can have more and even more and more degrees. So if we have triangle that has fixed number of degrees, and we have other triangle, what he calls triangle, that has not fixed number of degrees, greater than 180 degrees, but not fixed, because it can be less or more, just more than 180 degrees, but it is not constant, because in planar normal triangle we have fixed. It is just 180 degrees, no more, no less. So you cannot equivocate, even if he says that this is kind of triangle, okay, but you cannot equivocate. You cannot say that they are the same, because they are governed by different rules. You cannot say that they are the same.
He did say essentially the same, but I mean, this
Yes.
is another, again, this is Dionysianism creeping in. There's two truths here, that they're both triangles to this man.
No, and they are not the same. This is just sophistry, pleonasm after pleonasm, or soletism after soletism. adding strange words, essentially the same, possibly shortest distance. This is not mathematical description.
Mathematicians agree, apparently.
Some of which aren't as easily distinguishable between the two as Euclidean and spherical geometry is. For example, Euclidean and hyperbolic geometry, the Euclidean plane and the hyperbolic plane define lines exactly the same way. Like
The same way, like in spherical, but not the same way like in Euclidean. So
Yeah.
they are both different from Euclidean. So, okay.
hyperbolic geometry satisfies the first four of Euclid's postulates.
See, why is he talking about hyperbolic? Because he's
I have
not.
no
He's just
idea.
shifted off into a different type of geometry altogether. I don't know why he's doing that. That's like saying he could just keep going to Euclidean and say, look, there's loads of proofs in Euclidean geometry. I mean, that's not spherical geometry either, and that does actually have proofs. And that satisfies all of the axioms. Not just the first four. Every one of them.
And uses the definitions, the common notions. Those lines do exactly the same thing. There's no difference in how you define them. And so how do you
Lines doing
distinguish those
things.
two things,
Yeah, he thinks hyperbolic
said that.
satisfies all of the evens.
Yeah, and they are doing the same things.
Mhm.
Yeah. So working lines. Okay.
What it doesn't do is develop into the third dimension, because Euclidean geometry is the only geometry that makes it into the third dimension, reality. Because Euclidean geometry is the geometry that we use within reality. As is a ball. That's where balls exist.
Yeah, that's right. It comes apart at the fifth postulate.
Yeah. Mm-hmm.
And that is what some people would say.
Yeah.
The test for Euclidean space is whether or not the fifth postulate holds.
Yeah. And that's precisely what my video that's going to be coming out in the...
Let's say that again. Blue marble.
Fifth postulate.
Yeah. Mm-hmm.
And that is what some people would say.
Yeah.
The test for Euclidean space is whether or not the fifth postulate holds.
Mm-hmm.
I cannot understand what Blue Marble is saying. He's
Well, he
mumbling
says-
something, but I cannot understand, literally.
He says that the test for Euclidean space, like I said, Descartes did this, is by you measuring the angles of a triangle. And they, if they add up to 180 degrees, then you're using Euclidean geometry. You're in Euclidean space, therefore you should use Euclidean geometry. Which is what we've been saying. Like, in reality, triangles have 180 degrees. But this man, this is why we did this video, like we said at the beginning, he said that's a lie. So, apparently, according to what Blues just said now, and what this man said earlier, we can deduce that this is not Euclidean space. And these people will be able to prove it by measuring a triangle with more than 180 degrees. Like Blues just said.
Yeah, but this is, for me, it is general problem with this guy, with this scholar sauce. Because he said that this is a lie. So this is his opening statement, let's say, that statement that triangles have 180 degrees is kind of a lie. And now through the whole process, he's using these triangles, which are a lie, to prove something. I would say that it is some kind of moral problem here, because how could you convince to anybody, when you are admitting that you are using lies to prove something? I just don't understand this process of thinking. Because he said that this is a lie. And now he's using this lie to prove something. It's just, I don't know. For me, it is just insanity.
Yeah, Blue Marble. Is Blue Marble on his way in? Is he, has he joined to help us out? Or has he sent Iridium in to cover for him in the chat? Because he's done a runner.
Yeah, that's precisely what my video that's going to be coming out in hopefully this week will be about, is talking specifically about Euclid's fifth postulate and what that says about Euclidean geometry and the advent and discovery of hyperbolic geometry.
Yep. I look forward to that.
Yeah.
That's a trick, right?
Everything's
Yeah,
a trick to you,
Because
Bev.
call it
Any
fate or whatever.
sufficiently sophisticated.
Everything to you is a trick, Bev. I can't imagine your confusion when the water in the toilet disappears after you flush it. Very intelligent, Blue. You can't work stuff out. You can't even imagine it.
Sophisticated mathematics looks like magic to those who don't understand it.
Yeah. Yeah, what did I say? I can't imagine
No,
your confusion
I would say
when the
that
water
it
in
is
the
quite
toilet
opposite.
disappears after-
Magic tricks looking like mathematics. That's quite opposite. This is what they are doing, for example, with this algebra. This is magic trick looking like mathematics. For example,
it's not even a magic trick though, because you can see it's just he's explaining how you do spherical trigonometry and, you know, the conceptual down to the unit circle using pi to derive the radians. This is all a way to conceptualize the circle into the sphere with pi to make it a self-contained system. But I mean, there is a bit of a trick, obviously, because these guys have fallen for it. They believe that they can use Euclidean and the relationships of the straight line to the circumference to derive not that. They've fallen for a stolen concept. Quite clearly. And they can't see it yet. Now, we did try and tell them this quite a long time ago. We can see the stolen concept within this. And we understand the Euclidean use, but I don't understand the not that, how they imagine that it's different somehow. And if Blue Marble or Scholar Source would like to come in and the help from Blue Marble Science will be greatly received. Come in and help us out how to understand how you derive not that by using the Euclidean principles of that. I'm guessing you won't. You'll keep talking about this sort of stuff amongst yourselves.
Flush it. Yeah. That's
Where does it go?
where did, yeah. It was here a minute ago. Where did it go?
I can't see it with my senses, so it must not exist anymore.
Got to be a trick.
Yeah, it's got to be trick.
Sigma minus pi has to be, can't be 0. And if we were in Euclidean space and triangles as proved to be 180 degrees, then that minus pi would equal 0. And he's
That's
saying
a
it
true
has to
statement,
be
what he
greater
just
That
than.
is true.
Now, to be fair, what he just said is a very true statement. If we were in Euclidean space, sigma minus pi would be equal to 0. That's exactly true. But we're not in Euclidean space right now. We're talking about something different.
Yeah, I
Mhm.
disagree. No, he is not in not Euclidean space.
Yeah.
Surface of the sphere is not Euclidean space. It is Euclidean space. It is part of Euclidean space.
Mm-hmm.
So he's not talking about something else.
No, he's imagining the radian to be a radius length, but it's the part of the arc around the circumference. That's why he's using pi in relation to it, because pi is a ratio of the straight line to the curve, and he's implementing that radian around the curve. He's using the ratio to express it on the curve.
Yeah, but this is still Euclidean, so nothing with a spherical geometry. Not existing spherical geometry.
This would be more Euclidean than you imagine, really, because pi's like the ratio. He's using the ratio of within the Euclidean book. Within I can't remember which one it is. Is it 8, 9? Book one of the books deals with proportions and ratios. That's what they're doing here. They're using the ratio of pi to implement the radius around the sphere, using pi within their equation. It's just a way to standardize the whole package to make it a self-contained unit. And you'll notice that he's not using numbers really, so it's closer to Euclidean than this guy imagines. That for him to imagine that it's not Euclidean is that's the confusing part. And if there has been any tricks involved, that this is where it is. It's going on in the mind of these people. He's just proven that a spherical triangle. Nobody's proved anything by saying that if you put greater than there, that doesn't prove a thing. It just says you've made it has to be situation from a mathematical statement. Trying to relate it to a triangle for some reason. Mathematical sign. Well, so he's what, circular logic, or reifying the answer that he wants? It just has to be bigger than it.
Yes, but this is where his calculation fails, because if sigma is...
Wait a minute. There was a bit of text there I missed.
Yes, but still, can you put this text? Because this text, Blue Apple Science does not, I think, understand what he is really writing. Because what he is writing... Pardon?
Mathematical sign. Get to it. Well, so he's what, circular logic, or reifying the answer that he wants? It just has to be bigger than it.
Yeah.
That's about as simple as it gets, Bev. If you don't understand it, that's a you problem. Well, in the fact that we do understand that it's fallacious, the part that I don't understand is why the university professor has teamed up with Blue Marble Science to expose the fact that he can't relate this stuff to reality. He's living in a mathematical concept. Whereas we're talking about reality, which is 3D. And the only geometry that makes it into the third dimension is Euclidean geometry. That's where triangles have 180 degrees.
Can you, Beth, put this film a little rewind? Because I want to deal with what Blue Marble Science wrote before this about this spherical triangles.
That one.
Just text before.
Yeah, he's just proven that a spherical triangle has to have
yes
an angle greater than 180 pi.
Yes, remember that this guy said that they are essentially the same. And this, what Blue Marble Science is now writing, is contradicting. Because if spherical triangle has to have angle sum greater than 180 degrees, and normal triangle has 180 degrees, therefore he proves that they are essentially different, not the same. So this text is contradicting what this scholar source was talking about. And he is proving that by stating this on the screen. He does not realize what he is writing, really. Because there are many contradictions in this film, because Blue Marble Science, maybe he thinks that he's supporting Scholar Source, but he's contradicting him. Because Scholar Source said that they are essentially the same, and on the screen we have why they are different. Curved lines and different degrees. So they cannot be essentially the same. Sorry for that intrusion.
Yeah, no problem. We'll go over it again. I'll play it and we get
Something different.
mathematical sign. Well, so he's what, circular logic, or reify him the answer that he wants? It just has to be bigger than it.
Yes, but this is where his calculation fails, because if sigma is totality of three angles, and that would be 180 degrees, and if pi is 180 degrees, it means that it has to be 0. So I cannot see where is this inferring, where is logical inferring, how he got that it has to be greater than 0, because from his calculations it is that it has to be 0.
I mean,
Right.
You don't understand that for the triangle to exist, it has to have a positive area, paper?
No, it creates area, so he's antecedent and consequent relationship. He doesn't know logic very well, it seems, but it is not a point. Point is that if he is trying to prove that spherical triangle has to have more than 180 degrees than normal triangle, you cannot take spherical triangle and subtract normal triangle from spherical triangle and say, therefore, it is proven that it is more. It is not how logic works. You cannot prove, because you are assuming already the sigma is this spherical triangle. It represents three angles of spherical triangle. It is not true, in fact, but okay, let's give them this concession for a while. And he says that this sum already has more. So if in his premise is this sigma, which is greater than 180 degrees, subtracting pi does not prove that spherical triangles have to have more than 180 degrees because it is already assumed in sigma. It is circular reasoning. Therefore, it cannot prove anything, even if it was true. That is my point. You cannot prove anything using circular reasoning. And this equation, this sigma minus pi, is begging the question, is circular reasoning. This is my point, because he said, and Blue Marble Science on the screen is writing about that it has to exist, so it is proof for existence of triangles, the spherical triangles. So you cannot prove a thing that you are already assumed. This is just nonsense, logical fallacy.
Yeah, I'll put it out in the chat. If anybody's looking at the chat in YouTube and all of that, you'd think that we were having a completely different conversation. I think it's just the model afflicted people going on in the YouTube chat. We're talking about straight lines and triangles and geometry here. I don't know what the a fantasy idea is that's going on there. Stick to the geometry. That's what we're dealing with. This is where the proofs are, within this geometry.
That's literally what the last 3 slides were about. You know, if you had followed along and did the algebra, you'd see that it worked. I mean, one of the equations is, the first equation I write down is proved geometrically. You know, if you think there's a flaw in the logic here, find it. But there isn't one.
I just pointed out. Yes.
In fact, if you want to.
Yeah, I think we've pointed out many flaws within his logic here. He just relies on the equation to be the proof.
Yes, but his last equation, this sigma minus pi, it is begging the question. It is circular reasoning. Because he already assumes that sigma is greater than pi. Because if he says that if you subtract pi from sigma, it will give you always a positive number. So he assumes, of course, that sigma is greater than pi, because otherwise you cannot infer anything else. So sigma has to be greater than pi. And therefore, he's proving what he has assumed in premise. It is circular reasoning, sorry. Just my statement about logic, because he's saying about logic. Yes, I spotted fallacy. This is fallacy. This equation, last equation, sigma minus pi, is circular reasoning. I'm talking, let's say, talking to scholar source.
Well, he asked for a problem with the logic, and this is what we're doing. We're pointing out the problems within the logic for him. We're giving him exactly what he's asking for.
Yeah, so if he is asking if there is a flaw, yes, this is a flaw. This equation, in brackets, sigma minus pi, forget this arc squared, it doesn't matter. This is circular reasoning. And this is logical fallacy, formal logical fallacy. And you cannot use formal logical fallacy to prove anything, because you cannot prove anything with fallacy. You can only prove that you are fallacious, you are using fallacious reasoning. So, not worthy.
No.
A challenge. I mean, go find any actual math professor at a university and ask them about this, and they won't. There's no flaw in the logic here.
Right. So this is a professor from a university who we have the chance of asking, because he's going over to Blue Marble Science and making videos. So we are once again asking him to come over and have a chat. Like he's just said there, go and find a university professor. Well, we have. He's here. He's over at Blue Marble Sciences channel, rebutting a rebuttal to what he's asking for. He could have just come over here and asked and told us himself. Let us ask him.
You can ask them about it, and I'll tell you it's correct. Not that that's, I mean, that's an appeal to authority, so I guess it's not really a, a thing. But if you can't find the logical error, that's what I mean. Like, go ask an expert.
Yeah.
See if they can find a logical error. That's what I'm trying to get at.
But we've already found the logical error.
Yeah.
Lots of them.
Yeah.
Go find somebody who's an expert in logic and mathematics, so a math professor, and ask them to help you find the error in the logic. They will tell you there is no error in the logic here.
Or just
So
ask
now-
your,
Sorry, now what he's saying now. So let's say that some mathematician created that equation, and he is referring us, he's sending us to that mathematician, supposedly, and he will say that there is no error because he's an expert in logic, supposedly. You cannot be a judge in your own case.
Well, I think a mathematician would say that the pi is the 180 degrees, and showing that there is a subtraction of that would mean it's not a triangle that they're dealing with.
Yeah.
They would be
Exactly.
honest about it, right? There is no problem, because the problem comes around when you want to call it a triangle and say it's basically the same or essentially the same, when it's not the same at all. That's the problem. So, Scholar Source, Andrew Parry, come over and have a chat. Like you've said, we'll discuss it, and we will explain to you what we consider to be the fallacies, and you can talk to us and explain why they're not fallacies within this new mathematics. We'll all learn from this experience. Pop on in anytime.
child who's taken high school math.
Yeah. I mean, I think this is an argument this is something I could present to at the most a trigonometry class, but I think you could probably make this argument in like a 8th or 9th grade geometry course.
Easily, easily.
Yeah, it's all based off of the surface area of a sphere. As soon as you have that, everything else can fall into place. I mean, even the argument of what the surface area of a loon is the same argument of how you find the area of a sector in a circle. It's just the ratio, right?
That's
the
right.
angle ratio to 2 pi or whatever.
That's right. If you can define the
He's once again stating entirely Euclidean. And Blue Marble has not once mentioned spherical pi. Who's dragging who along here with the misunderstanding of what they're talking about?
And basically, he's repeating his another fallacy, because he said again that when you have this area, then you have pi. No, when you have pi, then you have area. So that would be the second or previous. So we have two, or at least, as I remember from today, two fallacies. One, circular reasoning with this equation, sigma minus pi, and now he's saying that because we have area, therefore we have pi. No, it's completely opposite. He's confusing antecedent with consequent. Area is consequent of pi. Pi is not consequent of area of the sphere. So at least two fallacies, formal logical fallacies.
The ratio of that angle to the entire circle, yeah, you can find its area very quickly.
Yeah. So if you can understand that and know what the surface area of a sphere is, I think this argument is accessible to you. I mean, I guess as long as you know how to do a little algebra too, I suppose.
Yeah, there's not a lot of algebra involved in this, but whatever.
Yeah.
From his calculations, as I can see, it has to be 0, not greater than 0.
Yeah.
No
So
paper.
not to interrupt them again.
Good.
So this, sorry, I didn't mean to interrupt you, Blue. What he's saying right here is kind of a little frustrating about this, because he's like, by my calculations, this is what it would be. He completely ignores everything else that I've said up to this point. He has not followed along. He hasn't found an error. He just says, I know what the answer is supposed to be because that's what I think it should be. And so that's what it is. So he must have an error somewhere. Now, to be fair, like if you do know a fact and you find something that's contradictory, you should be skeptical of it. I'm comfortable with that. But then go find the error. Like go find what the issue is. And in this case, what the issue is they're making too hard of an assumption that everything in the entire universe behaves like Euclidean geometry when they barely even know what Euclidean geometry is. And not every surface satisfies Euclidean geometry. And that's the assumption that's wrong, that's leading to their wrong calculation or their wrong notion of a fact here.
Wow.
Again, I can repeat theta 1, theta 2, theta 3. Please explain what these angles are, because they are 3 angles. So please explain where these angles are and what they are. Because I think that he explained at the beginning, and they are not angles of this spherical triangle. So that's why it should be 0. But if he is talking about angles in spherical triangle, so he is starting from spherical triangle to prove spherical triangle. It is circular reasoning. So anyway.
It's just a
fallacy
portion of a
after
sphere,
fallacy.
though.
Yeah, he's talking about this area of this portion of the sphere. He is not even naming it a spherical triangle, but he's talking about 3 angles, theta 1, theta 2, and theta 3. And from his clip, it is not, I think, maybe I am mistaken, but it is not angle between these curves. So that's my objection. From where he has these angles, which are sum, and the sum of this is called sigma. So that's my question. What are these angles?
Well, let's see where he takes it.
Tells us then that the angle sum of a triangle minus pi is strictly greater than 0, or that the angle sum of that triangle is strictly greater than pi. Now,
What tells you
it
that?
is
Because he
impossible.
just wrote it down that it has to be.
algebra tells you that.
Same comment. Don't know what this
Yeah,
is.
so he's, yes, so, and you are right, yes. So it has to be greater. Why? But he's talking about triangle. And we know that sum of angles in triangle is 180 degrees. So if you have this sum and you subtract pi from that, you have 0. Simple.
The algebra. Same thing we've just said about 10 times, guy. Pay attention, fellas. For the triangle to exist, it has to have an area. That area has to be positive. It can't be negative. It has to be a positive number. That's where that comes from.
Yep.
He's wrote greater than.
Wishful thinking.
Just
Nothing
because
more.
he wrote greater than, that means that it has to be.
Do you
And
know
by the
of
way,
a triangle, Bill,
sorry,
that
can you
has
stop
no...
for a second?
Yeah.
He's making a false equivalence, because he's equivocating area with angles, number of angles. For example, if we have a square or any figure, planar figure, it is not related. The area of the square is not related with angles, because square has 360 degrees always, and it can have more or less area, because it is about the side length of the sides, not about angles. But he's saying that because this area is positive number, so it is existent. Yes, I agree. I don't disagree that this area is positive, but it doesn't prove number of degrees. It is just non sequitur. It is.
Is he saying
just
because it's
red
got
herring.
more than 180, it's positive? Or, you know, just because it's got more angles than nothing, that it's positive?
I would say that he's creating strawman, because he, as an answer to my objection, he is talking about area of this section of the surface. It is strawman. It has nothing to do with proving that triangle has more than 180 degrees.
That's
Talking about
that's what
area.
Larry Scott said to my son. Because my son was asking where the triangles are that have 180 degrees. And according to this, there is none. An infinitely small triangle would still have more than 180 degrees according to this rule.
Yeah, which is absurd, of course.
So it doesn't leave any space for the triangles that do have 180 degrees, the real triangles. And that's what these people are unwilling to talk about. Because we're talking about triangles within reality. They're saying they want to put a ball there. And I say, it doesn't matter where you put the ball. Triangles will still have 180 degrees.
Area. Please show me one.
Well, and I think that's the thing that. Oh, go ahead.
We'd call that a point, I guess.
Yeah, you know, and that's the thing that I think he's missing. You know, he's claiming that I just threw that greater than up because I wanted to, like, because there was no reason to put that. That greater than 0 is there because of a geometric fact.
Yeah.
That if you have a triangle that is non-zero, like an actual triangle with area where the lunes don't just make a single point, because a lot of this argument doesn't follow if you don't have an actual triangle there. So we're necessarily in the scenario where you have a non-zero triangle, not one that's just a point like you were saying.
A non-zero triangle that's a point.
Yeah, so he's
what's
talking
that?
about
There's
this.
no such thing. It's not a triangle.
Yeah, so he's talking, he's naming triangle, this spherical triangle, which he's now calling non-zero triangle.
Yeah, which is 180 degrees. He's saying about them having to have more than 180.
Yeah, but this is still, he's talking about not triangle, and he's using, in fact, because pi is, in fact, in his equation, because sigma is sum of 3 angles, which supposedly creates triangle, because figure with 3 angles is always considered to be triangle, and pi, which is 180 degrees, so it suggests that it is also a representation of figure like triangle. So he's subtracting from spherical triangle normal triangle, and he says that the number of it has to be greater than the 0. This is what he's doing, but his sigma is spherical triangle, and pi is Euclidean triangle. So again, he's using a Euclidean triangle to prove existence of not Euclidean triangle within Euclidean space, because of course sphere is part of Euclidean space. So this is just magic trick what he's doing.
Not a very good one, but I mean, he's certainly working on blue.
Maybe
So
blue
we-
is convinced. I am not.
Yeah.
No, in this context, geometrically, that triangle has positive surface area. That is a geometric fact. All I'm doing by writing that down is representing that geometric fact with symbols. Like, that's a geometric statement, that the area of that triangle is greater than 0 is a geometric statement.
Greater than 0. 0 means above 180. He's got 0 as being 180 now.
Yes, but still, this is just silly because, of course, we know that normal triangles have area. We can calculate them.
Yeah, that's with 180 degrees, right? But that's not allowed within this framework. That's what I was saying earlier. He's put a greater than there. And his 0 is 180. That's the traditional Euclidean triangle. He's just named it 0. So when Blue Marble's talking about positive, he's talking greater than 0, more than 180. They've literally made a 180-degree triangle disappear from existence within this.
But I agree, and which is, of course, absolute nonsense, because it is positive area always, because if you have no positive area, so you have 0 area. You cannot have negative area, because it is nonsense. It is less than 0 area. It is just nonsense. You cannot have less than nothing. So it means that he's comparing two areas, and I don't know where he's going with that, because we have positive area with normal triangle and positive area with this spherical triangle. And yes, because this surface is curved, we can say that area of this spherical triangle is greater than area of normal triangle because of this distortion. Yeah, I agree that area of spherical triangle, this figure they call spherical triangle, is greater than area of normal triangle if you have fixed points in the same space. But you need same space, Euclidean space. Just normal connection between points, straight lines, and on the surface of the sphere. That will give you greater area. Yes, I agree, but what it has to do with number of degrees in angle in triangles. It's just nonsense. He's making some kind of argument, but I cannot see where it goes, because it doesn't make any sense. Area of this spherical triangle and area with normal triangle. How could it prove that spherical triangles have more than 180 degrees with that? It's just non sequitur. I don't know.
That I'm using, but he thinks that I just wrote it there because he didn't understand it. You know, that I just picked it out of nowhere, which I understand. Like, a lot of times that's how it feels when you're not following.
No, nobody's saying you just picked it out of nowhere. That's ridiculous. You're meant to be a mathematician. Come on, think about it, please.
along in an argument, in a mathematical argument, that it feels like these are just coming out of thin air. But it's not. And if they would delve down into this and try to understand it a little bit more and maybe learn a little algebra, they would realize that it's not, that it's not just coming out of nowhere. Now remember, that's
strictly is an authoritative word, isn't it? Kind of says this is proof, this is definite, this has to be,
Yeah,
so
it's
that's
equal to, right? The equal sign. Yeah. There's no strictly equals within mathematics.
Well, just to clarify this like ridiculous argument, this is maybe again another place where we use.
What ridiculous arguments he talking about? Nobody's made an argument. Stop presenting these things as arguments. They're just sort of clarifiers that we're going over.
A little math jargon, right? So you have a greater than or equal to sign and a greater than sign. Sometimes to emphasize the fact that the greater than sign does not allow equality, we'll say strictly greater than, to make sure that it's clear that we are not allowing it to be equal to that thing. So when I say the area of the triangle is strictly greater than 0, I'm saying it's greater than 0 and it is not equal to 0. And to his point, we do sometimes say strictly equal to, again, to emphasize the fact that it is exactly equal to. It can't be something else.
That's a pleonasm. Exactly why I said that. You don't have a strictly equals to, because it's either equal or not equal.
Or not equal.
Yeah.
Yeah.
That's the way logic works. Not strictly equal to. Pleonasm.
It's just a way of being a little bit more to emphasize the point, as opposed to just saying it, and potentially being misunderstood.
Right.
But it's totally mathematical term. Like we use it in math all the time. You find it in any math textbook. Go for it.
Oh yeah.
He's sophistry. Words of the sophist.
That's me.
This goes on for another hour as Scholar Source calculates the area of a triangle on the globe with 1 degree of spherical excess. All right. So it goes on for another hour where he does calculate the area of a triangle on a globe, not a sphere. So he's putting it into reality, or he's turning the globe into a sphere. One or the other.
Well, it goes on for another hour.
Yeah.
And I do have a little bit of it. And we can listen to how confused they get.
Just clip some bits out.
As you try to show them what 1 degree of spherical excess amounts to.
Yeah.
Hey, let's listen to it.
It is.
Well, listen to a
Sure,
little bit of
let's
it.
do it. Yeah.
Oh, I'll put a link to this in the description.
I don't get it. I don't get it.
I don't get it.
You can tell the geometry that you should be using by the amount of angles within a triangle. This guy has just said flat would have more than 180 degrees.
No, I didn't say flat would do that. I said that a sphere would have more than 180 degrees. A triangle drawn on the surface of a sphere would have more than 180 degrees. I never said a flat. In fact, I specifically said the opposite.
He said 2D.
Yeah, 2D is flat. So
I said a flat triangle in a flat space, like a flat Euclidean plane, would have exactly 180 degrees.
Yeah.
I think the part that maybe you skipped over here is I was talking about how we determine curvature, and we can detect intrinsic.
But see, Blues there says that's a lie. Well, he said 2D. That's why I'm saying flat. I consider flat. Blues completely clipped out the bit where we were emphasizing the fact that he said 2D, and I consider 2D to be flat. So Blue Marble wants to represent that as a lie. I suggest Mr. Alan Parry should come over here and have a conversation with us rather than let Blue Marble misrepresent us to this man. Because he's not doing a very good job here of representing what we're saying. He's clipped bits out. Dishonest. But we sort of expect that from the Blue Marble scientists.
Intrinsic curvature by the size of the angle sum of triangles. In fact, I've got, I don't know if you can swap to a video camera on me, but if you want, I have a couple of 3D printed models that can actually show something kind of cool about this. If you
3D printed models?
I'm gonna turn a light on in here too. The lighting in here is not great.
Oh, it looks good here.
Oh, does it look okay?
Yeah, it looks fine. But
okay, I'll just leave it there.
Okay, so after a brief pause for me to get my equipment readjusted, we're back. So what do you got?
Yeah, so wanted to talk. We were talking about you can detect curvature by the angle sum on a triangle, right? So I have here a 3D printed sphere that a colleague.
See, isn't that the same as the thing that we were going over earlier that I presented? So he's coming with a model that's similar to the one that we've already presented earlier, and Blue Marble laughed at us for it, didn't he?
Yeah.
Hmm.
So he's talking about sphere, a solid object,
yep,
a surface of this, and he draw some figure on that surface with curved lines, of course.
I think it'd be an eighth of a sphere that represents.
Maybe, who knows?
Yeah. They always go for the 90, don't they? The quarter of a hemisphere.
Of mine printed out, and you can see on this sphere, this is an equiangular right triangle. So if I can adjust so you can kind of see the outside of that line.
Did he say an equiangular right triangle?
Yeah, he said that. Yeah.
It's not, is it? That's not an equiangular right triangle because they don't exist.
Yeah. Equilateral triangle, yes, and they have both equal
60.
sides and equal, 60 and 60 degrees. So
yeah,
equal sides, equal degrees.
Angles, yeah. But there's no such thing as an equiangular right triangle. So that's impossible. Yeah, this man, he's trying to show it, yeah. It's like Fight the Flat Earth and he's orange, putting pins in oranges.
There is a right angle. And the outside of this line here is also a right angle. And then if I go up to the top, that angle is also a right angle. And so here you have a sphere, right, with an equiangular right triangle. So again, here's an example, just like in the video, of a sphere that has more than 180 degrees in a triangle. My camera stopped focusing. But so this surface is called positively curved, and we can detect that by the angle sum here being bigger than 180 degrees.
So yeah, so he's talking about positive being more than 180.
Yeah,
it's positively not Euclidean, not a triangle.
It's more than Euclidean.
Yeah,
more.
It's positively not Euclidean, with an extra curvature to one of the lines, obviously.
But if you take another surface here, and boy, it really does not want to focus. To get that, you can cut that part out while I'm trying to get this.
He's not going to cut it out.
Camera to focus. Jeez. So this here is a hyperbolic paraboloid, or half of one anyway, because we cut it in half. And I've drawn a triangle on this one too. This is also built out of geodesics on here, and you can see that that angle on the end there is a right angle. And if you look at it this way, you can tell that this is an isosceles triangle. But if you look at the angles on the bottom here, those angles are definitely smaller than 45 degrees. They're congruent, but they're definitely smaller than 45. So this triangle here has less than 180 degrees because it's a triangle drawn on a negatively curved surface. And a negatively curved surface just means that it bends one way in one direction, but another way in the other direction. So this saddle point here, bends this way, but it also bends this way. So it's bending down here and up here. And that's what makes it negatively curved. And when you have a negatively curved surface, you end up getting triangles around that point that add up to less than 180 degrees. And you
said it's bending. It's bending.
Yes, but this is just bending surface. So we know that surfaces can bend. So no problem. But
Like
bending
but he
surface,
said,
you cannot draw a triangle.
The point is that he said it's bending. That's in relation to the Euclidean straight line. Right? He's relating it to the Euclidean straight line and saying that is bending. So that's not hyperbolic then. Obviously, he's doing this in Euclidean space.
Yes. Yes. So because if he's saying that this line is bending, and supposedly in this hyperbolic geometry, it is straight line.
Yeah.
So they are all three, because they have different curvature. These three lines have different curvature. These two are even close to be straight, but they, of course, they cannot be straight.
Yeah.
But they are different. They are curving in different way.
Yeah, because these, like Eric says, this is a 3D printed model, right? Now, the only geometry that applies to 3D is Euclidean. These hyperbolic and spherical that he's talking about are only 2D. So you can't make a 3D printed model of a 2D thing. It's impossible.
Yes, exactly. It is impossible to reduce 3D to 2D without distortion. So you cannot. So you have to make 3D model, because you cannot say that it is 2D and you have 3D model of 2D space. This is just oxymoron. How can it be?
Yeah. Well, even when he explains it as bending, right? It's obvious that he's talking within a Euclidean framework.
Yeah. So 3D. So he's showing 3D object, this like clepsydra, let's say. This is 3D. We can see and compare with him and surroundings. It is 3D object. And he says that this 3D object is 2D. This is just insanity.
Yep.
You can detect it that way. That's kind of what I was talking about in this portion of the video that we kind of cut out. But, you know, so it's just like, that's what I'm saying. And if it's flat, then when you try to draw a triangle on it, like a piece of paper, that's when you get 180 degrees.
If you just take 3 points in space, in any 3 points in reality, in 3D space, you will form a triangle with 180 degrees. That's what we're saying. 3 points anywhere.
Yes, you don't need a piece of paper for that.
Mm-hmm.
So we can detect how curved something is by the angle sum of a triangle on it, which is what I was pointing out earlier. The fact that you can draw an equiangular right triangle on the surface of the Earth and have all three sides be congruent.
I'd like to see him do that.
Yes, he's talking about.
I would like to see him do that. We just I want to maybe clip this.
Then when you try to draw a triangle on it like a piece of paper, that's when you get 180 degrees. So we can detect how curved something is by the angle sum of a triangle on it, which is what I was pointing out earlier. The fact that you can draw an equiangular right triangle on the surface of the Earth and have all three sides be congruent, that shows that it's a sphere. You cannot have that geometrically on a flat piece of paper, like on a flat plane or anything like that. It is not possible to have three straight lines that are all the same distance with three right angles between them. It's not possible to do that.
It is impossible. Yeah.
Yeah, it's not possible to do it. Like, what's he talking about?
Yeah,
I
so
want to
he's
get this
saying that he cannot have three straight lines on the surface of the sphere. This is what we are talking
No, but
about.
he's saying about it proves it's a sphere. Like, you've listened to the first
of a
bit.
triangle on it, which is what I was pointing out earlier. The fact that you can draw an equiangular right triangle on the surface of the Earth and have all three sides be congruent, that shows that it's a sphere. You cannot have that geometrically on a flat piece of paper, like on a flat plane or anything like that. It is not possible to have three straight lines that are all the same distance with three right angles between them. It is not possible to do that on a flat plane. If the Earth was flat, you couldn't make such a triangle.
The Earth isn't flat.
Yes, and by the way, he's talking about the consequence of sphere, because he said that it proves that it has to be a sphere. No, it is just proving that on the surface of the sphere, you cannot draw a triangle.
Yeah.
This is what
there's
we
no
are
straight
talking
lines.
about for years, I think now.
Yeah.
You cannot draw triangle on the surface of the sphere, or hyperbolic, or whatever.
Why did they
Because-
always bring the flat Earth into it? This has got absolutely nothing to do with the flat Earth or any of his whatever he decides he wants to imagine about flat Earth conceptions or whatever. We're literally talking about a triangle in reality. Any 3 points. Got nothing to do with the flat Earth. This guy's saying the triangle has to have more. He says he can draw on the Earth, on the land, a triangle with 3 right angles. This man says he can do it. Just recorded him saying it. And he says that proves a sphere. So this man being able to go outside in the Earth and mark on the land 3 right angles on a triangle proves a globe to this man. That's how you get mathematical proofs in reality. It's a good job that he might want to come and have a chat with us about the Realising Euclid. And then he can show us how he does this. 3 right angles.
The fact that we can make such a triangle on the surface of the Earth is a mathematical geometric proof that the Earth is a sphere.
No, it is non sequitur. You
No, he
cannot
says
prove...
you can. He can do it. He's a mathematician. He's just said he can do it.
Yes, but he's just
him
insane, or he doesn't know what he's talking about. I
He's
think
with
that
Blue Marble
he's-
Science. Blue Marble Science has obviously told him what is and isn't possible, like on Earth, right, on the land, to be able to draw a triangle. I mean, triangles have 180 degrees, but this man, he can pop in another right angle somewhere. Just
yes, and
squeeze it in.
he doesn't realize that he's again creating circular reasoning. So I don't think that he knows what proof is, because he is repeatedly using circular reasoning, and he thinks that it will prove something, because if he is, let's say that he is going to do that impossible task to draw a spherical triangle, of course he wouldn't know that he drawn a spherical triangle, because you cannot check that. And so it is circular reasoning because he already assumes that he has drawn spherical triangle. Therefore, it is a sphere. And this is circular reasoning. This guy doesn't have any clue about logic, how logic works.
Oh, whoa. This guy's the mathematical chair of a university. If he says he can draw a triangle with 3 right angles that proves, it makes a proof. Go back and listen to him again.
The same distance with 3 right angles between them. It is not possible to do that on a flat plane. If the Earth was flat, you couldn't make such a triangle. The fact that we can make such a triangle on the surface of the Earth is a mathematical geometric proof that the Earth is a sphere.
There you go. So like this man has got a proof that the Earth is a sphere because he's drawn a triangle with 3 right angles.
On the ball.
He's done it, yeah.
On his model. So
no. He said on the Earth. Not on a ball. Like he's done it on the Earth. On the land.
So this is just insanity.
It's a geometric proof of globe. 'Tis globe. I mean, blue marble. I mean, we've been asking for this sort of stuff for years. And this guy's here at Blue Marble Science. See, that's why he probably searched out blue marble. Because, I mean, mathematical proof, a geometric proof. I would really like to talk to this man about his proofs. Because we did a proof video. I think it's 2 or 3 years ago now.
It absolutely is, and what I'm laughing about, I'm thinking about something I said to these guys a long time ago, and they have had a lot of fun thinking they caught me in a mistake of some sort. But I said to them one time, I said, it depends on how you define things. If I want to define a square as an object that only has 90-degree internal angles, I can have a 3-sided square on a sphere. I can have a 4-sided square on a flat sheet of paper, and I can have a 5-sided square on that hyperbolic surface.
Mm-hmm.
So it's interesting.
He's nodding, but he's not saying anything.
3, 4, and 5-sided squares again from Blue Marble Science. I mean, what a good guy. What a good guy. Look at him. He's going along with you, Blue. You think you're blocked, Blue? I've not got you blocked at all. You know that, Blue. Stop lying. Click the link. You are not blocked from this server at all. Has anybody seen Blue at the in the landing? A Blue Marble Science. There you are. You left the server. Why did you leave the server, Blue? You joined and then you've left. Why did you leave? And then try and tell everybody in the chat that you're blocked. I'll just show everybody here. Look. This is Blue Marble Science. Here. Blue Marble Science just left the server. So he's joined, and then he's left the server, and then he's joined, and then he's left the server again. Yeah, he's trying to tell everybody in the chat that he's blocked. Terrible, Blue.
If he was blocked, he wouldn't join and left.
Yeah.
And leave.
Twice.
It's impossible.
Right, we'll carry on. Finish this. It's good job that you've got a proof now. You've got the mathematical chair of a university with a proof for the globe. Blue. You should use that one a lot more often.
What happens when you move away from just a flat plane?
Yeah, very fascinating, very rich branch of mathematics. And I tried to explain this to them in their comments that they made on the video, that we've come a long way from Euclid. It was about 2,400.
On their comments. You see, I've only made the initial comment. You can type in the live chat, Blue, and we'll give you the role for the VC. It doesn't... You're not blocked, Blue. We do have some mods around for helping Blue out, can you? He's just type in the chat, Blue, that you're in, and then we can get you the VC role. We can't just have any old person coming in with gratuitous globe science. Let everyone know. Is Alan with you?
100 years ago, and we've learned a lot about geometry since then, and we've learned that not everything is Euclidean. To be fair, it did take us to about 2,000 years to figure out that you could have a plane that was non-Euclidean. We knew about spherical geometry, but if you take it that sense, then I guess Bev and his group are only about 200 years behind the times.
A plane that's non-Euclidean?
Which one? Can he name plane, non-Euclidean plane?
Yeah.
Because the sphere, of course, the surface of the sphere is just Euclidean, so he cannot say that this is not Euclidean. And it is not a plane. So that would be very strange.
We're only 200 years behind, so he'll be able to come and explain to us how a ball is somehow different than a sphere.
Yes, so it means that we just missed developing nonsense.
Yeah.
And I am happy with that.
I'm okay with it too.
That's not too bad.
Maybe not as bad.
Yeah, let's see if I can hop back to...
turn my video off.
Yeah. And
yeah, I brought those models out because I was going to use them for the video that I'm making.
Yeah, I like those models. Those are nice.
Yeah.
So anyway, back to
nice models.
Back to where we were. When all else fails, just lie about it, right, Bev? Because that's what he just did.
I bet Flat Earth Math helped him. Paid him for that. Got his proof. Non-Euclidean space. It's 2023. It has to be.
180 degrees, and it would be so imperceptible when it's small that you'd probably never be able to find something that can measure it. In fact, on the surface of a sphere, we could figure out exactly how large a triangle would have to be in order to exhibit an angle sum that's even 1 degree larger than 180 degrees. Well,
oh, here we go. You can determine through pi, probably. Probably going to do it through pi.
What we want to do is we want to have our angle sum minus pi to be 1 degree larger. We have to convert that 1 degree into radians. To convert degrees into radians, we multiply by pi over 180, which is a conversion factor because pi radians is equal to...
He's making an angle. What's going on there?
180 degrees.
180 degrees. He's doing that thing for you here, what do you reckon he's doing? Turning the degree into... What's he turning the degree into?
Doing something weird? I mean...
Converting degrees to radians, yeah. That's what I think.
Pretty.
Turning degrees into a line, a length.
Yes, and that would be straight line.
Yes.
And Euclidean straight line, not great circle. Not great circle.
Equivalent to the radius. The radian.
Simple.
Yeah. Maybe try listening, Biff.
Can you tell?
Radians.
Yeah, but do you know what a radian is? Herbert.
Yeah, it's the diameter line from the center to the edge of the sphere or circle.
the radian, right, is if you think of the angle as being the little bit at the center, you know, between the two straight lines. Well, a radian is the circumference of the measure of that angle. So it's the same as an angle, except it's related to the end of the radius, right? So it's the angle.
What?
To be fair, he's like 50% there.
He's almost, yeah, I know. He gets almost there, and then
he gets almost there. He's just trying to explain it. If you cut it up, then you never get to actually explain it. But yeah, go on. Hopefully these guys will explain it much more succinctly.
falls off the horse.
Yeah, if you form an angle, 1 radian, the unit 1 radian for an angle is the angle in a circle that sweeps out a radius of arc length on the edge of the circle.
Right.
That's where he's getting the circumference thing from, right? So if you want, you could think of it this way. A radian is the angle, or an angle measured in radians is telling you what portion of the circle that you're sweeping out as a ratio of it to 2 pi, right? So it's like, it's on a scale from 0 to 2 pi, but if you divide by 2 pi, that's the fraction of the circle that you swept out. So it's actually measuring sort of how fast or how far around the circle you've gone.
Yeah.
It's just, it's basically the same thing. I mean, degrees does this. It tells you it in a fraction.
The degrees tells you the exactness because it gives you exactly how long it is. But what they're dealing with is pi. So you just have to imagine that it's something to do with the radius, but there's no particular value because they're dealt with radians and no particular value. But the moment you relate it to an angle, then you are putting a length to the radian, and therefore you are putting a length to the radius.
Yes, because it is. If you are using pi, it means that you are comparing this to this diameter. So in that way, half of that diameter. So you have to know because you know this ratio, so you can have this radius. But we know that. So what is the problem? What he's trying to prove? That we are wrong at what? Where we are wrong about this radian. We know what it means and what it does. That's okay. But so what's the problem? It is part of normal geometry. I don't understand why they are discussing that.
Yeah, it's not difficult, is it, to work out how the radian... In fact, I've got a thing, I'll post this. This is a guy on Twitter that I follow a lot, Tim Bresney, and he's a teacher, and he well, thank you very much, Gods, with the memberships. Thank you, everybody. Say thank you to Godzilla. The guy is just done a drawing to show sort of an animation to show exactly what the radian is and how that's worked around the sphere.
Fraction up to 360, right? So if you divide by 360, you get that same fraction.
Yeah.
So if you take an angle in degrees, divide by 360, you'll get a fraction. If you take that same angle in radians and divide by 2 pi, you get the same fraction. That's what it's meaning.
Yeah, I said,
anyway.
what did I write? I said,
so what would the area of a 540 degree triangle have? Would that be more than 2 pi? Because he said 3 pi, didn't he?
Yeah.
That's interesting, isn't it? More than 360.
More, yeah, more than full circle.
Mhm.
It's just strange.
More angles than a circle.
It's an angle whose arc equals the radius of the circle.
Exactly.
That's what it is.
57.1.
It's the same as an angle, except it's related to the end of the radius, right? So it's the angle measured in radians are on the circumference, not just an angle in the middle.
I think he just said a radian is actually a radian.
Because
Yeah,
it's related
like
to
that.
the length of the radius, right? The
Yeah,
radian is linked to the radius.
It is
So
the
it's
length
how
of the
they
radius,
imagine
Bev.
the circumference as being a distance.
Not related. It is.
Okay.
It's quite a clever trick, really, because you
Not
can
a trick.
imagine that the radian is different than an angle.
It's a unit conversion.
That's all it is.
If this
The unit conversion. Yeah, it's the same thing.
Same thing, yeah.
Just
yeah.
a different way of saying it. So, it's a magic trick. Rather than considering it two straight lines and the angle between the two, you're considering it one curved line. It's a magic trick. It's the same thing, but just the way that you can look at it differently. Typical for the globe, guys.
is a trick, then talking about kilometers and converting to miles is a trick. I mean, like, it's just a
Not the
unit
same.
of measurement.
That's all. Nothing more than that.
It differs only because if you have longer radius, then you will have longer distance of the circumference.
Oh,
But it
Jesus.
would be the same portion, the same angle. But of course, length of that circumference, this portion of circumference, would be greater. But the angle will remain the same.
So it's the distance.
I
of the
mean, I'll
points
appreciate
between
this
the
is
two-
probably the
between
most
two angles
genuine
where the-
part of this entire video commentary that they're making. They're actually trying to talk to each other to try to understand a mathematical concept.
No, we are not. We already understand it. We're just going over for clarity for the people that may not understand what's going on here and the way these people are just relating the same thing to something different. Everybody understands what an angle is, but when people say radians, it sounds like it's something different. It's just not. It's just a different way of looking at it, and that's all we're trying to do is explain how this difference is actually the same thing.
Like, if they did this the whole time, they'd actually have made some progress on this. Like, they're talking back and forth, trying to figure out what a radian is, and like, that's probably, you know, a healthy conversation to try to figure it out and piece together what they all know about it. It's too bad they didn't, like, you know, Google it, but because that might have been a little faster. But at least they're trying to figure out what this means here, and that's a good thing about this conversation. To be fair,
Yeah, and that's part of the reason I put it in here.
Probably
This
the
part
reason
was
why I
not
left it in.
so bad.
the
Yeah,
radius.
but this is just normal Euclidean calculation, so I don't know what,
of course,
what
it's a
he's trying to
Euclidean
prove.
calculation.
Oh, it's even admitted, of course it's a Euclidean calculation. That's handy.
Yeah, so not spherical geometry.
Yes, and not
That's all
definitely
my
not
point.
spherical. Yeah, well, we've got this far at the end of it, and he's admitting it's 2.5 hours of a 2 hour 42. And he's saying, yeah, of course it's Euclidean. Well, thank you very much, Blue.
And this is a clarification for flat Earth math because he had some objections to that.
Yeah. Yeah, this is
That
the whole
the
point that
radian
we were
is-
saying. This has been entirely Euclidean. So will you please stop saying it's not Euclidean? It's non-Euclidean.
You can't derive non-Euclidean if you're using Euclidean mathematics in order to be able to get there. You can't use Euclidean to get to non-Euclidean.
Yeah, well, we could do
Everything's
it with
Euclidean, right? That's what
we
they're
do it
saying?
with a Euclidean pencil on a piece of Euclidean paper.
This is just trying to convince you through a mathematical equation that a radian is the same as an angle. I don't know why he's using it. Why they don't use angles? Because I think it's because they want you to envisage this as a distance, right? They're getting an angle. Remember that saying? You can do fuck all with an angle. They're trying to pretend that they get a distance, right?
What? It's 2 units of measurement of angles. That's it.
Right, but except this one's a radian, which is a length distance. It's a unit of length within this. You just want to try and convince people, like I keep saying. Like Ruhif wants the opposite side to the angle by putting a ruler on a picture. This guy wants to use the radian at the opposite end of the angle within a circle. It's a sort of a gateway sort of thing to get you to sort of imagine that you've got the angle here, but over there, there's a length unit that you can use. But that all requires you having the length of the radius before it makes any use. Unit circle sort of stuff.
Oh,
It's
man.
funny.
You know, I don't know. Bev's from the UK, right?
Yeah.
I mean, it is a good thing he lives in the metric system, because, like, if he had to deal with all the conversions that we use with the imperial system we inherited from the UK, I mean, he'd go nuts. I mean, he
I understand 33 feet. What's the problem? Does he think there's some sort of a conversion from radians to angles? Or does he not understand the concept that we're trying to get across here? I'm guessing that he doesn't understand what we're trying to say. It's a bit too core conceptual for this man to understand what we're trying to get at. This is advanced simplicity.
he'd be struggling. It's just as weird that 180 degrees is pi radians, that 8 ounces is a cup, or 5.
No, I think this mathematician's been living in university a little bit too long. Or maybe Blue has poisoned the well a little bit too well. You should have come over here, I'm telling you. Alan, pop in, have a chat.
5 milliliters is a teaspoon. I mean, like there's no difference. It's just a unit conversion.
That's all it is. That is all it is.
Oh, well, this man obviously doesn't understand how they have to have an angle being different just yet, does he? Because of spherical pi. It's really strange to me that Blue Marble has not piped up and said a word about spherical pi yet. Because that's where this man's going to come into problems.
Radians happen to be very convenient. And if it weren't for the fact that we eventually end up making things, and some guy in the shop needs to mark out an angle, we would use radians all the time for everything. But that's pretty damned inconvenient to try to use that obnoxious little pi thing to measure angles in the shop.
Yeah.
Degrees make a lot more sense.
Yep, a lot easier to delineate it out that way.
Yeah.
Tell you what, though, if you've ever seen somebody try to do calculus on trigonometry,
Radians is a mathematical thing to keep within the concept of pi being the relationship between the diameter and the circumference. You don't need to apply numbers if you can do it that way. So therefore you're doing the conceptual understanding of the circle and the straight line. You're keeping it as a core elemental type thing within mathematics. You don't actually use radians out there. You measure things within degrees from a reference point every time.
Metric functions in degrees, it is gross.
Oh my God.
There's all sorts of conversion factors that have to be thrown in there. You know, like something as nice as the derivative of the sine is the cosine. Nope, it's got a conversion factor in it because you have to deal with the fact that you changed how you're measuring the degrees. You have to like slow it down. It's really weird. You end up getting some weird chain rule stuff. It's very bizarre. And it's not nearly as pretty.
Yeah. I can't imagine the confusion that would ensue if I had to hear air traffic control say something like moving 06 Quebec, turn left heading 2.13 radians.
Right.
What?
So there's right.
You want me to do
and
what?
so, exactly. So what we really learn here is that there are contexts where one unit's better than another unit, and it's okay. But if you're going to talk about different units, you got to be able to convert between them, and that's what we're doing here.
Yeah, that's all.
That's what he's doing here.
So in some sense, we're actually multiplying by the number 1, just with units. So 1 degree times pi over 180 is just pi over 180. So if we take our angle sum and subtract pi, we want to get pi over 180. So a triangle on the surface of the Earth, in order to have an angle measure that's 1 degree larger than 180, so to have an angle measure of 181 degrees, would have to have a surface area equal to pi over 180 times the radius of the Earth squared. Well, the radius of the Earth is about 3,958.8 miles. If we square that,
this is where the whole point of using r comes into it. Now he's adding a value to r. He didn't measure that, but he's like, this is where the trick comes in. He's now going to apply a numerical value to this.
And multiply by pi over 180, we get about 273,529 square miles. That's roughly the size of Texas. So in order, there's actually a funny story about why I know this.
Is he still playing that? Yeah.
Computation. So when I got to UVU, I was trying to think of fun hands-on exercises that I could do with students, trying to do something engaging. And I had this, I had just put together a few years before I built a talk that was around this idea of proving that the angle sum of a triangle and a sphere is more than 180. I mean, it's a classical proof. It's not new or anything. But
doing it in reality is definitely new, right? Applying it to reality, absolutely.
I was messing around with that, and I was like, hey, we could detect the curvature of the Earth with this. And so I
wow, he's been there. This is when he started. Why's Blue kept this guy out of the way for so long? We've been asking for the proof. This guy's got it.
I'm from Utah, obviously, because I teach at Utah Valley University. And in Utah, there's the Bonneville Salt Flats, which is an incredibly, I hesitate to say flat region. It's an incredibly flat part of the Earth in terms of elevation, right? So
there are still elevation changes, though. So technically, you should say it's not flat.
Carry the same elevation all the way across. It's huge. And I was like, we could set up some large triangle, maybe with like laser techniques or whatever, to try to measure angles and lines here and see if we can get a detectable difference in the angle sum. And so
wow, he is doing it. Setting out triangles. He could do it from mountaintop to mountaintop. got some good technology nowadays.
I wanted to figure out how big would we have to make this triangle in order to have a detectable difference. And so I was like, 1 degree off. How big would it have to be? And I did this computation. I was like, yeah.
Has he not like worked out what's the smallest angle that you could measure within these tools? Or does he just go to 1 degree? I mean, does he know anything about measuring angles with the tools that they have today? That's where I'd have gone first, rather than just for 1 degree. See whether you can measure something smaller. Like, because you can measure a distance, can't you? I mean, we went down, like, you can measure a millimeter, couldn't you? If you wanted to. You would have the ability to measure a millimeter. So, I mean, why is he particularly taking 1 degree?
Yeah, this is probably not going to be doable on the salt flats. So it's just the salt flats aren't big enough to detect anything.
Like I say, why don't you see if you can measure an angle smaller than 1 degree?
Yeah, and by the way, I still cannot see connection with proof because
It's going to measure a triangle with more than 180 degrees. Doesn't matter how much more. Like a second more. 180 degrees and 1 second is still more than 180 degrees, isn't it?
yeah, but it is impossible because if these lasers are straight lines, it is impossible.
He's got the proof, though. He's he's just said, to blue marble, he's got the equation there. That's the proof. He said he's measured 3 right angles. So, I mean, like he said there, he'd struggle with 1 degree, but he just said earlier that he's measured a triangle with 270. It's gone quite a lot more.
But to have this in that manner as he wants, you will have to have curving lasers. But
No.
He's
just talking about the consequence of having a triangle on the sphere.
Yes, but if you are using lasers, you are using them in the air. They are not on the surface of the sphere. So
yeah, coefficient of refraction of 1 matches the curvature of the Earth. That's what one of the great globe guys have said. So that's all you'd have to do is get lasers that work within the range of the coefficient of refraction of 1. And then you'd be able to measure your triangles of larger than...
Yes, but this is circular reasoning because it is the curvature is already as I said. So it means that the laser is already curved because of refraction. So refraction is curving laser. So
no, it says no. The actual thing is to match the curvature of the Earth. Well, if the curvature of the Earth isn't any, like a horizontal, let's say, for instance, then a coefficient of refraction of 1 would just match that, wouldn't it? It's not saying that there is any curvature; it just says it would match it.
Yes, I agree. Yes,
yeah.
This whole refraction is only to prove that you cannot see curvature because of refraction. This is what refraction is for. To rebut claim that...
there's no need to deal with refraction, though, because this guy's talking about mathematical methods, isn't he? This guy's talking about the mathematical proof that he holds.
Yes, but so why he's talking about lasers and refraction?
Well, yeah, that was a hypothetical thing that he was doing. And he decided that he couldn't do it. So he must have come to a different way. Yeah, have we got... Is Blue back in again or not? No, is he not come back in? No, he's left the server. If you do come back in, Blue, we can give you the role to come into VC. But if you keep joining and leaving, there's not much we can do about it, unfortunately. We'll wait until Andrew comes, anyway.
Well, with some good, actually, with some good theodolites.
Oh, here we go.
But probably
Yeah.
not, just simply because you won't be able to get far enough above the surface to see far enough.
Exactly. Yeah, you'd lose line of sight before.
Yeah, you're going to lose
because it
line of
goes
sight
over the-
way before you get a triangle large enough.
Blue should be telling him about reciprocal zenith angles, shouldn't he? That's a much better way of doing it. This mathematician should easily be able to tell him about that. But, I mean, I guess they're stuck on triangles, right? Because this video is about triangles. So you could use the Gem Panda method and conceptualize 3 triangles on the 3 points at the top of mountains. Like they did when they were doing trig points, when they were mapping the land. Like that sort of stuff, because that actually has been done. And from what this man's saying here is that triangles have to have more than 180 degrees. They'd have to already know about it. This guy's... It's a good job that this mathematician's got involved with this.
Now, you know, some of the big triangles that the geodetic surveyors have surveyed way out west. Some of those things were pretty huge, and they were able to get spherical excesses of, you know, in the arc minute range.
There you go.
Right.
But you're not going to get 1 degree.
Right. Yeah, see, there you go. See, Blue Marble's saying that they've already done it. Triangles with more than 180 degrees. That's two.
Agree.
Right. Well, and this is what should really make people appreciate what's going on with why flat earthers are confused by this.
A flat earther's confused about this. Why is he talking about flat earthers? Why is this man talking about flat earthers when he's just said he can prove that triangles in reality don't have 180 degrees? Why's that got anything to do with flat earthers? Is he trying to say that the teachers at high schools are the flat earth teachers that teach the lie or something? I mean, what's he saying? He might just be obsessed with flat earthers.
Maybe.
Yeah.
The Earth is so enormously big, and the scale that we live on it is so amazingly small.
The scale is small. What's that? What does that mean? It's a ratio.
Yeah. So I don't know what he's talking about.
It's a small scale.
That these differences are imperceptible. Every one of these manifolds that we talk.
Is that imperceptible? Didn't Blue Marble Science say that they did actually measure it? And hasn't this man said that he measures it? So why is it imperceptible if they're measuring it?
Yes, that would be contradiction.
That's a contradiction.
Not first.
Talk about spheres, hyperbolic paraboloids, or just a hyperbolic plane, all that stuff. They all have the property that the small...
Did he say hyperbolic plane?
I'm not sure. Maybe.
Because we were asking for a different sort of plane, weren't we?
Differences are imperceptible. Every one of these manifolds that we talk about, spheres, hyperbolic paraboloids, or just a hyperbolic plane, all that stuff, they all have the property that the smaller you go, the more Euclidean-like it becomes.
That's right.
Oh. The smaller you go, the more Euclidean-like it gets.
Yeah, this is the same thing that this spherical triangle is more and more Euclidean as it gets smaller and smaller. So,
Yeah, but that's what he was
same
talking
idea.
about. He was talking about a zero being a point. That's a triangle with 180 degrees. They were talking about a positive, which is more than a point. They've reduced a Euclidean triangle to a point. That's what they've done. They've literally made Euclidean geometry into a point. They've vanished it. Yet they're going to use entirely Euclidean understanding to derive their bit that they're imagining is beyond that point, the reality. This is fascinating for me, and I would love to talk to Alan. If you please come on in and have a chat. There's a link between reality and mathematics. Come and have a chat about it.
And if the largest circle you can see before you go off the surface of the Earth with these massive geodetic surveys that you're talking about can only acquire spherical excesses in triangles in the arc minute range, I mean, come on, the Earth is huge. It's supposed to look flat on a scale like that.
Wow, it's supposed to look flat. He is a flat earther, isn't he? He is. It's
Maybe,
supposed to look flat. I'm pretty sure flat. That's what flat earthers say, isn't it?
Definitely sounding more and more like that as he goes on.
Observably flat. Yeah.
That's what bothers me about that observation. That it's another one of those things where I'm like, listen to math, guys. Going out and looking at your visible area and saying, hey, it looks flat, that is not...
He's the one that said it. He's the one that said it. Is he rebutting himself? Let me go back. He thinks somebody else just said this.
In the arc minute range? I mean, come on. The Earth is huge. It's supposed to look flat on a scale like that.
It's supposed to look flat, right? He's just said that.
That's what bothers me about that observation. It's another one of those things where I'm like, listen to math, guys. Going out and looking at your visible area and saying, hey, it looks flat, that is not an observation that...
It's supposed to look flat, he's just said.
Yeah.
Like he's literally contradicting himself. He can't make out whether he's a flat earther or a not flat earther. It's probably because of blue marble science there, putting the heat on him.
That distinguishes a large sphere and a flat surface. You cannot tell it from there because both a very large sphere and a flat space will look flat on the scale that you can see. So going outside and saying, hey, it looks flat to me, that means nothing. It doesn't logically distinguish between those two scenarios. It's a completely worthless argument.
Well, I don't know why he made it.
Yeah.
Because he's just rebutted and refuted himself. Completely meaningless statement he just said, that it's supposed to look flat, if you're not meant to say that it's supposed to look flat. But that's what he did, this man. Just to by the way, Scholar Source, if Blue Marbles told you we're flat earthers, we're not. And I would say it definitely doesn't look flat anywhere.
For either spot.
Yeah, the observation that is more practical that you actually can do is measurement of reciprocal zenith angles.
Oh, reciprocal zenith angles, he's coming out here.
Yes, and
Well
by the
done,
way,
Blue.
Jesse Kozłowski said that he measured the drop from horizontal, so
Yeah,
it is obviously measurably and observably not flat. Yes. because of this drop. So why he's saying that we cannot see on that scale? Jesse Kozlowski saw
Yeah.
at that scale, on that scale.
Yeah, perhaps he hasn't heard about Jesse Kozlowski. Maybe Jesse Kozlowski's left the arena and, you know, left behind a legacy that this man hasn't even heard of. Blue Marble's about to tell him now, though. Even Brenda knows about these reciprocal zenith angles.
Exactly.
Those
Exactly.
can be
Yeah.
done, and there you have enough variation that you
Simultaneous below.
And detect it.
can detect it, even over fairly short distances.
Fairly
of
short distances.
10 or 12 miles.
Right.
Yeah,
10 or
Absolutely.
12 miles.
you can get 8 or 10 arc minutes of deviation in the reciprocal zenith angles, and of course, that's something else that Bev and those guys have criticized me for saying time and time again. But
No, we've never actually had a chat about it, Blue, because you've never explained the method. We tried to get a word with Jesse Kozlowski and the main surveyor and Larry Scott, but they all seem unable to talk about it. In fact, two of them just ran off. They disappeared. They're gone. Never going to be able to explain it ever again. But luckily enough, we have the very test, the reciprocal rumpus pole sighting experiment, which we will be performing to prove the dogmatic globe. We'll help you out.
I can go back to the transcontinental survey and pull out data that was taken, and I'm talking about 150 years ago. And in some of those triangles, they were measuring over distances of like 175 miles.
Mm-hmm.
Incredible as that may sound, but they do it with a thing called a heliotrope, where it's actually a mirror, so that they can see the mirror flash.
Okay.
So you obviously you're not going to see another surveyor 175 miles away, but
Right.
with a large heliotrope, yes, you can see that flash, that mirror flash.
Mm-hmm.
Right, I like this, right? Because, I mean, this is right at the end, the last, like, 5 minutes. And what we've got here is a mathematics guy that's conceptualized a ball and this measuring angles. He has a rule that states triangles have to have more than 180 degrees. And Blue Marble Science here is paralogizing this very method into this man that's living in mathematical land. So now the combination of the two, this man imagines he has a proof within reality that Blue Marble has handed to him. So thank you very much, Blue. Anytime you would like to come and discuss the actual mathematical stuff, Scholar Source, come and have a chat. How we derive these things within reality. Literally the reciprocal zenith angles. That would be great, because we do have a series of logical proofs to lead up to a proof of the dogmatic globe about this very thing, which we will be going over next year.
And in some of those cases, you get a deviation in the zeniths being not parallel with each other by a factor of 2.5 or 3 degrees.
2.5 to 3 degrees, says Blue. Tilt of a vertical tilt.
That is supposed to be 1 degree per 69 miles on the land. So
he's going off that old picture that the guy that probably doesn't live in Maine did, like years ago, when I was talking to them on Twitter before I even came to Discord. Yeah, it's just a little graphic that they've made. Okay, I can get that out and sort of show you that. If Scholar Source wants to come round here, I'll show you where Blue Marble got his 2.5 degrees from. world record breaking distance with a theodolite angle measurements. It's fantastic.
So, yeah, it's pretty impressive.
It's pretty
And
impressive. Yeah.
if that is
And if it
true,
were
Like a
flat,
world
you'd have
record.
0 difference.
yeah, if it were flat, there would be the reciprocal zenith angles would have to necessarily add up to 180. They don't. They always add up to more than 180. Always. So
Always, yeah.
Always.
let's see what else is. Play a little bit more.
And the
of this.
radius would be Euclidean, right?
Yeah.
Because
Okay,
only the
great.
radius is Euclidean. It's a straight line. And his one is a 2-dimensional surface, so it wouldn't have a radius. The radius is Euclidean. But this is the triangle. I mean, it makes it impressive that the angle, some of the angles that these people have been measuring, that's impressive.
Well, I guess that's about all we've got. And just in the nick of time, we're coming up on 3 hours almost here. Alan, thanks so much for being with me. And I really appreciate all the effort you've put into this. Hopefully, everybody got something out of it. I don't know if we've taught the Try Thinking guys anything or not, but
Come over
you never
and talk
know,
to us
maybe.
at any time.
Yeah. Well, I think it's more. I really appreciate being on as well. I appreciate you giving me the opportunity to chat about this a little bit. I think if even if Bev and the Try Thinking guys don't get anything out of it, hopefully other people will. Hopefully your viewers enjoy it, and they can kind of see where some of these arguments come into play, and what the math is behind it. But yeah, I really appreciate you having me on. If I can make a plug for my channel, if you guys enjoyed this, check out my channel Scholar Sauce, and subscribe there. And we have a lot of fun there. I'm trying to make as many entertaining math videos as I can. So the more support I get, the more time I can put into it.
Well,
Hopefully we'll see you there.
Fantastic. Yeah, be sure to drop in and visit Scholar Sauce on his channel. A link to it will be down in the description. And don't forget to hit that like button. And with that, we'll see you guys on the next one.
Yep. See you later.
A couple.
Right, there you go. So that was what did Blue Marble call it? Scholar Sauce destroys try thinking. Don't think. Don't even try thinking. These guys will tell you what you should be saying. If you try thinking for yourself, you might just spot a contradiction, and these guys don't like it whenever you do that. They'll probably call you names if you spot a mathematician with a contradiction. They're probably embarrassed.
So you've not heard from Scholar Source at all?
No. There was actually I got a comment this morning. The thing that I posted originally on Scholar Source. Let's see if I can just get to this. This is the original video right now. Let me just sort this out. See that? Okay, so this is the one that that my original comment on this video, the original video that he did, and somebody replied to this. So this is the only contact that I've ever had with Scholar Source, right? So I say we do live in Euclidean space, though. something that's never really been addressed yet. A sphere is a Euclidean solid shape, so you should be aware of the self-refuting claim you make when you reference the plane to the surface of this solid shape. You made this video over a year ago. Have your opinions changed, and can you talk about the logic behind your statements? Hit me up. To which he replies, thanks for commenting, I appreciate it. I'll try to resolve your concern below, but please let me know if you have additional follow-up questions. You stated that we do live in Euclidean space, though. This is incorrect, it says. In 2 dimensions, Euclidean space refers to the geometry of the flat infinite xy plane. In the dimensions, it refers to our, and then he, obviously massive reply. And when you walk on the surface of the earth in a straight line, you don't follow a Euclidean line. Again, just loads of stuff, right? And then I put, thanks for the reply. We're a small YouTube channel that deals with the first principles of thought and gaining knowledge. Your opinion and critique of our review will be welcome. We'll be going over this video live on Monday at 8 PM. So, let him know what we're doing. Blue Marble replies that I've asked several times. Let's try again. Please give me a definition of Euclidean space and tell me why the surface of a ball is Euclidean space. Can you do that, Bev? Which I've done many times. Blue Marble keeps asking this question as though I've never answered him, but I have. I've answered him many times, particularly within this video, many times. And then a guy called the Goblin 957 says, just so you know, you're talking to a flat earther who thinks everything is Euclid. He straight up doesn't accept the existence of spherical triangles. Well, I don't know who he's talking about. Perhaps Blue Marble science, right? It's just somebody coming along poisoning the well, because I'm not a flat earther. Although this guy said it. Scholar Source says to this guy, thanks. I think I saw you in the chat of their live stream, the one that I asked him for a critique of. I glanced at it after the fact, pushing back against their denial of these mathematical facts. I appreciate the support and for your comment here too. Remember, he's not replied to me. He's replied to the Goblin who's told him something of an untruth. So he's thanking the guy that's lying to him. Goblin says, I was indeed in those trenches. Talking to flat earthers is a hobby of mine. Again, obsessed with flat earthers, nothing to do with us. Having a different conversation with a mathematics professor. Question. This is the Goblin again talking to this guy. What did you think of Bevstream? Personally, I found it to be unintelligible rambling. Yet he was in the trenches, apparently. Scholar Source replying to the Goblin. Sorry for the slow reply. I'll be honest, 4 hours is an awful lot of time, and I did not watch the whole thing, though I did skim through some of it. From what I saw, they seem to have completely misunderstood practically everything I said, including taking my initial joke in this video far too seriously when it was meant as a hook. That was about mathematics teachers lying, him himself being a mathematics teacher, supposedly. They got hung up on simple concepts like using, look at you, Scott. Do you know much about these guys? Come and ask us. Come and talk to us. Don't talk to some guy who's going to lie to you about us. Don't ask him about us. Come and ask us. Please. Scholar Source, you're meant to be an intellectual. You're meant to be a university chair of a mathematics thing. Why are you talking to some random person who's just lying to you? At first, I thought that they were just a bunch of flat earthers, but after glancing through some of their content, I can see them arguing with Nathan Oakley. So, like, this guy's told him we're flat earthers, and he's gone and looked and seen we're not flat earthers, we're arguing with flat earthers. So somebody's lying to this man. The Goblin says they are flat earthers, but they dresses it up in fancy lingo. No, lie. From this man. Bev and his crew basically asserts that level is the same thing as horizontal. Listen, Scholar Source, please don't listen to trolls. If you want to know anything about us, come and talk to us. Basically, Bev describes himself as somebody. No, Bev does not describe himself as somebody who thinks that. That's fucking ridiculous. And once again, you're lying, the Goblin. But apparently, professors of mathematics would rather talk to some YouTube troll called the Goblin than actually come and ask us himself. More replies, right? I reply, Scholar Source, you could come and ask us yourself. You won't get an honest answer from someone so model afflicted. I'll go over this tonight at 8 p.m. UK. Scholar Source, I see. Thanks for the explanation. We couldn't find your name to Google. Scholar Source doesn't seem to bring up anything. My name is in the title card of this video about 3 seconds in. Somebody called Sphera. You could come and ask us yourself. So he's quoting me saying to Scholar Source, and this guy's just quoting it. He says, don't. This is advice, again, from somebody else. Don't. Not if you value your sanity and time. So maybe this is why he's not coming, because somebody is just advising him to not come. The obvious disingenuous lack of self-awareness and gross arrogance should be enough red flags that no genuine conversation, much less discussion, will be had. These are the gatekeepers. These are the people that you have to get through in order to talk to the professor, right? He'd rather talk to these trolls and get what these guys think of us than coming and asking us himself. I say to Sphera, you don't have to come, but poisoning the well is a weak attempt to influence the channel owner. So that's me to that guy. Now, this is 1 day ago. This guy says, I suspect the issue here is touching on the fourth dimension. Now, if you hold up any triangle, such as a carpenter's triangle, yes, the angles will add up to 180 degrees. But under further analysis, the three angles are not connected to each other because space is all relative. So the angles, this guy thinks, the angles of a carpenter's triangle aren't connected together somehow.
And he is even making this drawing here.
Yeah.
In this comment.
It's just
so
that
we can
triangle.
see that they are connected.
Yeah.
So he's just rambling.
And then he says,
complete
everything
nonsense.
is always in motion. So everything is always disconnected. There is no vector in spatial reality which is straight. Because if it's only straight from one exact perspective at one instant in time.
And this is how to phrase it. Everything, it is contradiction, because if everything is in motion, it means that it has to be connected.
Uh-huh.
Because
Yeah, it's a
if
triangle.
if one thing is pushing another thing, and this another yet another, so therefore everything is in motion. But it means that they have to be connected.
It's
So
a triangle.
Yes, but he is making this statement that everything is disconnected.
Yeah.
Because everything is motion. And I am explaining how it is nonsense. Because you cannot say that everything is in motion because everything is disconnected, or everything is disconnected because of motion. It is quite opposite. This is, I don't know. This guy is an idiot. For me.
Yeah, it's a triangle. How can they not be connected? The three angles of a triangle, this man's trying to say, aren't connected together. That's fucking ridiculous.
Yes, completely yes. Insane guy.
Right, so I say, the carpenter's triangle has all three angles connected. The triangle in mathematics has a provable internal angle sum of 180 degrees. Do you deny this fact? He says, no, but also yes. Diletheism, right?
Troll. Or just troll.
Yeah. But then he says, right, this is his way. I say, I've noticed the contradiction prevalent amongst the diletheists. And he puts, well, isn't this a valid example of diletheism? Here we go. Do you believe the Red Sox will win the game tomorrow? I believe it's about a 70% chance. So that's a yes or a no. I guess it's both yes and no. And that's as far as we've got with that. The broken minds of people that thinks, you know, if you have to go so far as to separate the three angles of a triangle to say they're not connected, then you know you're in a really bad position. Not far away from a nutsacking, I would say.
Yeah, I think it would be respectful and polite for Scholar Source to come and speak to you, you know, face to face, because he's being put up as, you know, it's Scholar Source destroying Bev, destroying Try Thinking. So his name is being put forward through the proxy of Blue Marble. And of course, Blue Marble won't care what will happen to him. He'll just carry on in his way. So, yeah, I mean, talking to other people or talking to you through other people in a proxy sort of fashion is really not the way to do it. If he, you know, he's being put up as the face, as a destroyer, and yet he can't come and speak to you directly. It just seems very strange. Yeah, I mean, he should come forward and speak to you. It would be a much more honest discourse, really, wouldn't it?
Well, it would be better if he would have talked to me in the chat of his own video instead of talking to the trolls and asking the trolls about us. I mean, that's what I mean. He's not where we're going.
Speaking directly.
Yeah.
Yeah. And taking, you know, their opinion of who you are. And, you know, he obviously seems to know Nathan Oakley enough in some sense. You know, he speaks to Nathan Oakley, not sort of he speaks to some guy called Nathan Oakley. So kind of infers he knows something about him, maybe.
And he speaks about flat earthers a lot, doesn't he?
Yeah, I mean, his obsession with flat earthers, I mean, if that comes from being influenced by the opinion of others who say, you know, you're a flat earther and everybody here is a flat earther, and he's taking that as an opinion, well, that's not, you know, what you would expect of somebody seeking the truth or having the truth about something, that they would just take, you know, a hearsay opinion. Why not go to the source? You know, look at the ruler, not somebody telling you it's 6 centimeters from across the table. You know, look, you know, take your ruler yourself and measure it. You know, it's second-hand information he's trading on and talking to a lot of other people, but never to the person he's supposedly destroying. This is, yeah, ridiculous.
Yeah, I'm wondering whether he knew that he was destroying me, or whether that's just something
Yes,
Blue Marble was tagging on. You know,
part of the editing.
he
That's-
might
that's
feel
what I thought.
embarrassed about some of the things that Blue Marble said, and that
Yeah.
he's going to have to defend the things that Blue Marble was stating.
Yeah, because he's there in the title. It's him being pushed forward, whether he likes it or not. You know, but it's not like Blue Marble talks to so and so about something. You know, it's Scholar Source is doing this. This is the guy. He's Blue Marble's not saying it's him doing it. He's just hosting it, supposedly, and editing the video in an artistic way. Because again, at the end there, when you know, there I was in there. You know, you're talking about radians.
Yeah.
Well, the reality of it was that at that time, I wasn't really paying attention. And then you answered, said, "Well, what's he talking about here, Ed Bear?" And I thought, shit, this is a bit like sitting at the back of the class and the teacher saying, "We're listening, boy." And I thought, fuck. You know, I thought, what did he say? Did he say radial? You know, a radius, you know? So I kind of, plus it was, you know, the beginning of my time here. I was only just getting used to even speaking.
Yeah.
So I was caught in that, like a deer in the headlights. I mean, that's the truth of what was happening.
Yeah, sorry if
But,
that,
you know, he chose to...
I didn't mean to.
No, that's fine.
Yeah.
Not at all. Not at all. It's fine. You know, that's life. Yeah, I can sit here and say and admit it. You know,
Yeah,
I'm not
yeah.
going to hide it. You know, that's what was happening in truth. But he chose in the editing to leave that in, to try and, again, like he did last night, to try and give this effect that people don't understand something, you know, because he edited this carefully. You know, he chose what to leave in and what, you know, so that kind of gives a flavor to his audience. These guys are dumb. They don't even know what a radian is, you know, and what I'm saying is the truth of what happened. It had nothing to do with anybody's perception of those guys haven't got a clue. I was just, you know, caught, you know, not having paid attention in a sense, like I had been in class. And that's what it was. You know, I was back in class again thinking, oh my God, you know, yeah, you know, you weren't paying attention, boy. See me after class. You know, it was that kind of situation, you know. I'm going to get 3 of the cane because that's what happened to me in those days. You know, shit, oh my God, I wasn't paying attention. You know, what's going to happen now? And that is what happened, you know. So that's a product of my education, you know, that still feeds through today, you know, and that's the truth of what happened in that moment. But he chose to use it to kind of put some focus on the group of people here that also don't understand something or not paying attention, because he didn't have to use that. And he did it again last night when I was asking about sigma. And it was the same situation, you know, that was kind of, he didn't, yeah, just to give the impression that these guys haven't got a clue. They don't even know what a sigma is or a radian, you know, because it was carefully edited, you know, and with all the little sarky comments and all that kind of thing. I felt really, I had listened to it, and I just thought it was really in bad faith. And knowing, you know, a lot of the stuff that was in that had been cut out, and like you said earlier on, wow, they cut all that stuff out that, you know, where we didn't misunderstand something, we didn't go over it. You had, but he cut it out. So he doesn't want his audience to think something. I mean, this is like his personal thing, isn't it?
Yeah,
And
they cut out all of the parts where we did actually clarify what we were talking about.
I mean, yeah, so, you know, I feel this is quite deceptive, and it's some, you know, I think it's some personal thing that Blue Marble's got. And now he's, you know, he's using this situation to kind of...
he's using Scholar Source to have a go at us.
And Scholar Source, I don't know if he, you know, I don't know whether he's aware of the situations he's been put in.
Yeah.
Because, you know, if his
Scholar
students
Source
get hold of it...
doesn't know about the Realising Euclid Tests that we've got and the proofs within mathematics. No. And he doesn't know about any of that because Blue Marble won't have told him about that. And that would be
Yeah,
what I'd
he-
like to talk to this man about, is these actual proofs that we've got.
Yeah, well, I mean, what interested me was the bit where he said that the smaller it gets, the more Euclidean-like it becomes. And that's what interests me, where this crossover goes, because Euclidean-like is almost like, well, it's not Euclidean, it's Euclidean-like. But at the beginning he said, the Euclidean Euclid works on a flat Earth or a flat world. He's kind of saying, yes, it exists, but only it exists on a flat world. So there's another flat Earth kind of idea. But that's what interests me, is if these guys, are saying this is the truth, this is the way it goes. I'm really interested in the crossover where it changes, how it changes, in real terms, not this vague, well, it's imperceptible, or in the small, it's Euclidean-like. Go on.
I can resolve your problem because
okay, yeah, it's talking bullshit.
no. It is. They say because it is this zooming in problem.
Yeah.
Both sides are using this zooming in, zooming out. So he says that if we zoom within spherical geometry, we are zooming in, etc. And this spherical geometry looks like Euclidean geometry. This is what he said. But the problem is what I said before, that Euclidean space is the whole, and spherical space is part of it. So it is contradiction. You cannot zoom in to have Euclidean space, because in fact Euclidean space is the whole. So if you are zooming out, you are going to Euclidean space because you are going to the whole. So it is impossible. It is just nonsense what they say, because part of Euclidean space, which is the surface of the sphere, as I said before, cannot contradict Euclidean space. And by the way, if you zoom in, you are going just to part of Euclidean space, let's say smaller and smaller part of Euclidean space. So how could it prove that it is more Euclidean? Because this is what they say. So it is massive contradiction. It is pyramidal contradiction here. Because if you zoom in, as they say, and you can see Euclidean space, if you zoom in, of course, why not? Because the whole space is Euclidean. So if you are zooming in, it looks like Euclidean. Why not? But the problem is that if you are zooming out, they say, you would see curvature, to be short. But if you see curvature in Euclidean sense. So you are still in Euclidean space. So there is no point where you can enter spherical geometry. Because if you are zooming in, as they say, you are going into Euclid points of view, because it seems Euclidean, because it is so small. But if you are zooming out, you can see this spherical surface as a part of the greater Euclidean space. So there is no room to enter spherical geometry. There is no point where you can see spherical geometry as your frame of reference, because it is just an object in Euclidean space, or curvature, and you will see a curved line as straight line. So it is, for me at least, it is massive logical proof.
Uh-oh. Uh-oh. Am I still here?
Oh my god!
It is
Oh
just
Christ!
nonsense.
I don't know what's going on. I don't know whether the stream's still running or not.
Said close
I'm
stream
not
on
sure.
my feed.
Did it?
Yeah.
I think my
Yeah,
stream
paper.
just shut
No,
Yeah,
off.
for
good.
me it is still live. I
Are
think.
we on the YouTube? Because it's
On
not
YouTube,
showing.
yes.
It's frozen up.
On Discord. I'm good at Discord here.
I see. I don't know.
Right.
Hopefully we're back here.
Yeah.
It's all good asking you. It's nothing showing on my end, so I don't know. We might have to end this stream soon. Go on.
Yeah, paper. I mean, I totally understand what you're saying, and I accept that. You know, even if I don't, there's some details within that I don't understand. Now, I get that, but this is being described as my brainwashing, right? And these guys are still going to say whatever you just said to me. They're still going to refute that and say that's not so. And so and that's fine. But so for me, they aren't explaining it. You see, that's the thing, is that I've got to this point where I accept this, I understand this. They're saying it's not so, but they can't tell me in real terms where that happens and how that happens. You see, so I don't expect they can. And that's the thing. I understand what you're saying. I understand how that can't work. And they're telling me, they're telling me that, yes, they tell me.
Because you said that you are asking about this point where it's
Them, asking
ends.
them.
Yes, but
not you, because they're meant to be explaining it to me. And they can't.
At the point, they are
Yes.
reducing Euclidean space to the point.
Yeah.
But if it is a point, you can, for example, you cannot have pi. So you cannot have pi at a point.
Yeah, but it's like I said to Charles, I can look at Euclid's elements and I can read, these postulates, definitions, and axioms. But there's none provided for this non-Euclidean space that's, equal to that. They can't provide that. It's just the law of imperceptibility. It's too close. It's too small to see it close up. It's too far away to be able to see it, But we assure you it's there. And that if you think that a straight line isn't curved, then you're wrong. If you think that 2D is 3D at the same time, if you can't grasp that concept, then you're wrong. They're contradictions, aren't they? And there's no explanation for that from them. I know there isn't one. I expect them to be able to, give some simple explanation about what they have, but because they don't, I realize there isn't one. Not of you. I'm not asking of you, as I keep asking them. Well, where is this then? Where does this change in your world then? How can this be true at this point? It's all right to tell the children that there's horizontals and parallels and straight lines, and that it's actually a lie, and they somehow don't have the intelligence to be able to know whatever the truth may be. That's ridiculous. It's just ridiculous, And then they're going to say later on that, oh no, it's not that. Not what we told you before. Forget that. It only works over there. It doesn't work over here, And he keeps saying it's a lie. So
and by the way, they also because the trick from their side is that they are, when they are refuting you, they are not proving you wrong, because they cannot.
No.
And they are saying just it is not that. You are wrong because it is not that.
Yeah.
But they don't prove this not that to you also.
Exactly.
So you
That's
cannot.
what I mean.
Yes, they don't disprove you, and they don't prove their point also.
But he's
So,
I mean, he's head of the university,
yes,
and he can't do that. You know, so this is the thing. You know, so you go to hear somebody from another point of view who is the top of his game apparently, and yet he can't explain this. This is what it fascinates me.
Well,
You
it's
know, so
even worse, right? Because what you've got is the chair of the mathematics department of a university that's telling you the proof within mathematics of a triangle having 180 degrees doesn't and can't exist within reality.
Yeah. Yeah, no, I hear it.
So where
Exactly.
is that proof?
Yeah.
Where does
that-
that proof
yeah.
exist?
Yeah, that's what I mean. That they should be able to, not without some confusing equation or algebra or magical kind of stuff that nobody can understand. It should be just as easy as the straightest, the straightest, the shortest distance between A and B is a straight line. That's simple, isn't it? There should be something as simple as that to explain this crossover that they claim is there, that nobody can see. That's what I'm waiting for from them. I don't think it's there. I'm not in that illusion. But this is what I'm asking for.
Between 2 points cannot be a straight line.
Yeah.
Or not the
and
straight
so you
line
have to
you perceive. Because that is the one that comes with the proof of triangles having 180 degrees.
Exactly. They all fit together. And if you lose one part, you're losing everything. If you can't have the straight line, you can't have the triangle, you can't have all these things that are connected to that. Yeah. So, it's a massive amount to have to, it's a big lie. It's a very big lie. I can see logically it's not there, but I do expect somewhere that they should be able to come up with something just as simple as, the shortest distance from A to B is a straight line, just like that.
Yeah.
And they're all simple. When you look at the Euclid, when you've got through the Old English, they're just very simple things, aren't they?
Yeah, it's
very simple explanations.
Simple, because once you start at the beginning, then you're building upon what you've just learned, and you take it one step at a time, and it's a natural progression.
Yeah.
But
apart from the Old English, if you've got an 1800 version and you think, oh god, what was that? Use an F there instead of an S or something, just if you got way through some of that. But when you work out that they're talking about a right angled triangle or a perpendicular to a horizontal, you get, oh, that's obvious. Of course it is. That's simple, so I'm kind of expecting and looking for this equally simple explanation about this crossover where Euclid isn't Euclid anymore, or Euclidean isn't Euclidean. It becomes non-Euclidean in a way that, I could say, okay, I'm not brainwashed anymore if you're claiming I am, because Bev brainwashes people. Well, I can verify what you're saying in a book. So somewhere else, it's not your stuff. You're just explaining stuff from somewhere else, and the logic and the stuff you put together through that. And like most, he teaches it. They're teaching the same thing to the kids that you're talking about.
Yeah.
But they're claiming it's a lie. So you're not doing anything different to them. But they say it's wrong.
Asking why it's a lie. We've been told it's a proof.
Yes. That's exactly. And so that's the point. I don't expect it. I do expect that if it is there and they say it is, that it would be very simple, because then I could go, okay, and move on and understand the world better, if that's the case. But I don't feel any truth in it. Like we were talking the other day about, you know, the things you recognize truth as truth. You could read a book and there's just something in it, or something somebody says. I mean, that thing you said today about that image of that cartoon, that moved me more today than anything for a week. You know, it was just, really, a really incredible thought. And I thought, wow, that was really powerful. That really summed up a big lump of reality. You know, I saw inside your mind at the same time. You know, that was lovely. You know, and I was driving. You know, as I said to you, I'm driving, thinking about this concept that you've just painted. Not some mad brainwashing, but you know, that something that goes ting inside you, and there's a truth attached to it, and I'm really not hearing it from these experts. I'm not getting this sting of a light going on in my head and waking up to a new.
Isn't it? It's hard to follow what they were saying, because tonight, listening to that, Blue Marble diminished the Euclidean triangle, the one that you have a proof of 180 degrees. I don't know whether you've actually got a proof of that yourself or not.
Yeah.
But he diminished that to a point and nothing.
Yeah.
Literally, that of which has no part. That's where Blue Marble says that proof is. It's a nowhere. It doesn't exist. And Blue Marble's got spherical geometry to build upon that. He has positive angles, and the positive angles make the triangle appear, because like he says, the triangle with 180 degrees is the zero. It's a point. Now that tells me more about their mind than anything, really.
Yeah, and I'm you know, I know I'm not alone in what I'm thinking. You know, there's others out there also, you know, well, maybe more in the dark in a sense. You know, I'm much less in the dark than I was on things that I remember and things that I you know, I'm getting hold of. But like we said about, you know, the language of mathematics is off-putting, the language of algebra is off-putting if you don't understand it, and you know, you've got nobody to show you, or you haven't got a mind at the time to try and understand it. You know, so you don't, you know, you don't look there. It takes a bit of work.
Yeah.
You know, all this stuff takes a bit of work and time and patience and consistency. You know, you just got to keep at it and try and chip away at something and grab hold of an understanding of something. And that's why I went seeking experts, supposed experts, because I thought that they would be able to provide me with, you know, something coherent that backed up all these shadow giants. And increasingly, it's just crumbling and crumbling, just a pile of dust, and there's, you know, nothing substantial there. No thing, you know, this heart feeling of truth. I'm not getting any of that, you know. And it's not because I'm just shut off and I don't want to hear, because I'm quite willing to hear this stuff. But I'm just surprised they just can't offer a kind of a simple explanation of something as easy as, you know, A to B. But, but you know, I can also see, you know, the games being played at the same time. So I'm not just dumb about all this stuff, because, you know, I do understand a lot of these things. But you know, if you ask questions about it because it doesn't make sense, or I think because I missed something, and a lot of people never even got to there. Maybe some people never even thought about that, never had an education, you know, or something that they focused on enough to remember certain points, or did like I did and didn't pay attention, or was pushed out of the system so that I didn't engage with them anymore. And, you know, large chunks were missing to connect things. But you know, it's a genuine, honest search. You know, It doesn't reflect on everybody else here, because I was asking some questions that may seem simplistic and basic. That's not at all. But he did, so he focused on those points, I thought, in the editing, because there was a lot of, he said there was another hour which he cut out. So why did he leave in some of those aspects that would give an impression of a certain type? That was my thought about it. Yeah. And here I am owning up to what the reality was at the time, that I wasn't really, just wasn't paying attention at that time. And that's all it was. It wasn't any more than that, and it doesn't reflect on what or paper knows or anybody else here at all.
Yeah,
that's what they want to say.
It wasn't really a review of our critiquing of his video, right? To get clarifiers from him. He he was I think he was led by Blue Marble Science into a false narrative of what we were trying to do. We were trying to get to the core concepts of mathematics, but it seems like Blue Marble led him down the model affliction thing, because he had to there at the end assume that flat earthers, for some reason, I can't imagine why that would come into an understanding about a triangle.
Yeah, certainly what I got from it. And I'd really make an appeal to Scholasaurus, come forward, come and speak to Bev and everybody here, and clear this up, and have a discussion, man to man about it, and see where the
it's not going away. This conversation. I mean, they can just keep pointing at us and saying, well, we don't understand, but it's quite obvious that we do, and we've got proofs, and we can lead people through a natural progression. It's really easy to do. We've got it all set up. We can go through logic, we can go through geometry, we can go through advanced simplicity of all of these things, show you how the logic links to the geometry, and the geometry needs the rhetoric for you to be able to express it to somebody, because there's a lot of people that can lose this through a bad teacher, let's say. Not to say that it's a bad teacher, but just the way that the rhetoric gets pushed, and certain people may learn in different ways, and maybe what we're going to be doing is for more the practically minded person, the one that got distracted at school, that wasn't that good at following a script. Like, they needed to be engaged slightly differently, and that's what we intend to do.
Yeah.
Put some sort of enjoyment or some sort of sense of you achieving something, rather than you just being told it and given the shadow giant's words. You get chance to actually learn it and take it in for yourself.
Yeah, and I think when you're engaged in it and you're interested in it, it's much more valuable, because my kids, when they at that age when they're having to make their options and go for choose O levels and A levels and things, and they haven't got a clue what they want to be or where they want to go at that age. They don't know what they want to be. I mean, some children, maybe they've been pushed or whatever, or they want to be a doctor, or they want to be a specific thing, and they're aiming for that, focused on it, great. But for those who aren't, and I said to mine, well, at the moment, education is available to you for your whole life at the moment. And when you choose to want to study something, and something interests you, and you're really focused on it because it really interests in it, you'll learn much more easily. You'll be focused, you'll be in the whole thing. And just because you're not now, because you're going through all these hormones and all whatever's going on in your life, it's hard to focus. You're trying to work out how to be a human being and deal with people, and changing stuff in your body at the same time as having to go through this critical time at school, you don't know what you want to be or what you want to do, then, it's easy to be distracted. It's easy to, just not really engage and miss the chance to get those pieces of paper that will open a door to you in the future. So things that I know, things that I'm interested in at the time, I'm all in. I'm focused on it. It's not like when I was at school and I wasn't really paying attention, or they treated me badly and I just resisted them and just thought, well, I'm not going to do what you tell me at all, because you'll beat me or whatever might happen. All the stuff that goes on, whatever for anybody. But yeah, I think when you're engaged and what I'm learning now again and remembering, and it's sending me in a search, I'm much more focused on. I'm absorbing it much more easily than I would have any other time. So, this what I'm learning here, and different styles, like you said, people need different styles. Some people need hands-on, working with something in their hands to get hold of it, or seeing somebody do it in front of them and show them. Some can read from a book and get it. It's whole different styles of learning and absorbing knowledge. So I'm quite happy to be learning this stuff, and it's not abstract. It's not I can go and listen to some places on Discord and listen to some people spouting some speculation that has no basis at all. Lots of people are repeating that in this arena. They are, they just listen to somebody who sounds good, sounds like he knows what he's talking about, but there's no basis behind it. Whereas this is, it's not Bev brainwashing anybody. It's, saying, open this book and have a look in here. It's not my book. It's been around for hundreds of years. It's the basis of everything that's built on in maths and geometry. It's there. It is. Have a look, see what you find. That, and then somebody comes along and says, "No, don't look there. That's not true anymore." Well, why is it not true? Well, just believe us. It's not true. Well, surely you can tell me, how. But we were lying to you. Really? So what's the truth now?
The way if he
well,
said that, he said it was a joke. But I mean, do you really take that as a joke when a professor tells you that you were lied to?
Yeah. I mean, he's got several videos. I have looked at some of his others. I thought, was he talking about flat Earth or some model previously? And he's got one about why a straight line isn't straight, and he straight away comes out talking about lies again, that we lied to you. And then when you ask him, or he says about it, well, it's a bit of a joke. It's kind of an in-joke, or it's inverted commas lie. But he talks about this lie a lot. So you kind of wonder, well, once you got through university and you got to faculty level, is there another level of lies that you're going to be revealed to you? That you're not able to see because you're not high enough up the ladder and deemed to be intelligent enough to cope with this level of truth.
It's a lie.
Because you can tell a child anything. Children absorb the lie. They absorb the false things. They absorb all the bad things as well as the good, the truth, everything. They just absorb it. My daughter's been told about gravity. It's in her. She just absorbed it. That's what they do. It's what children do. So they could absorb the truth about it if it's a lie. Why not tell the truth if it is indeed the truth? I don't know why they're going to carry on telling the lie. And but he does talk about the lie quite a bit.
I'm gonna have to study up on this guy, because I mean, he's destroyed me now, hasn't he? I have to
yes
have to look into
yes.
all of this mathematics stuff a little bit deeper now. I just find it interesting, right? Because he was talking about flat earthers, and according to Nathan Oakley, the Earth is measured flat, whereas this man here, he's measured a triangle that proves it's a globe. So that appears to be in direct contradiction to the flat earther. So if there ever were a false dichotomy to be set up, then this is it summed up: the professor and the flat earther. Does seem like he's obsessed with it. So Nathan Oakley could prove the professor wrong by showing how the Earth is measured flat, and the professor could prove the flat earther wrong by showing how he measured the triangle with more than 180 degrees, as would be a necessity as stated by Blue Marble Science.
Because it's funny, because there's people coming here and attacking you for somebody else's claim, like Bob's Modus Ponens or the Black Swan or all these things, and you say, have you been over there? Did you go and ask them? Did you confront the source with it? And they haven't, and then you got now, scholar source come in, crushing you in this video supposedly, but not coming to the source, going through somebody else. It's a very strange situation. People aren't going to challenge the people who make the claims, and they're not coming to talk to the people they're supposedly refuting, just doing it through a proxy. Or it's quite odd.
Yeah, we're meant to be adults, aren't we? But this seem like schoolyard tactics? People telling tales and talking behind people's backs.
Yeah, it is very childish.
I don't get it, because we've had multiple teachers come around and have conversations. Matthew Learn's come around. Father Charles has come around.
They're like
some French guy years ago.
The statisticians and stuff.
Yeah.
I mean, this is a mathematics chair.
The truth is the truth. If it's the truth, you don't need to hide it and cover it up with some kind of, strange veil or something. It'll stand on its own, won't it?
Yeah.
Yeah, like I say, this coming year, we're going to be doing the advanced simplicity properly, and explaining all of the Realising Euclid tests, how we got there, the 12, the t-shirt logic, all of that sort of stuff. We're going to be going back over it again, but doing it since that was research, we're going to do the proper stuff. I'm done with this flat earth, globe earth ridiculousness. But I mean, obviously, through just talking about reality and proofs within reality, and how we derive these understandings of the mathematical proofs, to explain to simple people, and to give them that understanding of mathematics that they perhaps didn't get from the school, more of sort of a practical sense, more of the logical side of the mathematics and how it's derived. That's what we're going to be doing. Now, what these people are talking about are obviously, these are university professors and stuff. I think they should be encouraging this sort of learning process. They shouldn't be at odds with it. They should be trying to gain more people into the fold of mathematics. I also think, I can sell the globe better than anyone. I can sell the real globe. It's not flat. Definitely not flat. But all of the proofs within reality go to prove the real globe. Reality. Because that's what people imagine. When they think of globe, they think of their reality that they live in. So finding proofs within that reality, it should be easy, right? The proofs that all horizontals are parallel. The proof that triangles have 180 degrees. These are all proofs within reality. They go together to form the idea of the thing that everybody calls globe. They're not at odds with each other.
The moment you think that they are at odds with each other is the moment you start the nut-sacking process. Why should you have to give up either? Just go with reality and then you'll be fine. That's what we're going to be doing this next year. Definitely not flat. And we can explain to Scholar Source. I mean, he's talking about these reciprocal zenith angles. Well, just so happens we've got the Rumpus pole sighting. The reciprocal Rumpus pole sighting. It's already there. The same proofs exist. We can prove the dogmatic globe. We can help them. Where they assume there is no proofs, we can show them that there is. That it has to be. There are proofs within reality. And just as you can start opening the floodgates on the proofs of Pythagorean formula, right? Once you start and you start thinking about it, you realize that there's multiple ways to come to the same conclusion. Well, same one with the dogmatic globe, right? There's millions of ways to come to derive the fact that the globe's dogmatic, or at least the dogmatic globe. Sorry,
I remember seeing that for the first time, how many proofs there are for Pythagorean theorem.
Ooh.
It was like 50 or 54.
Yeah, 50
I don't know.
plus. I mean, it keeps going.
Yeah. It was kind of wild to see that.
But imagine how many proofs there are in reality that have to be denied. That's as many proofs there are as the dogmatic globe.
Yeah. Yeah, I mean, that's, those proofs that you have inside, they're really hard to, to let go of and crush, when you have them. It's not easily done for somebody to come along and say what you're thinking isn't actually real. I mean, yeah, we can live with some illusions, but some of these things are just, self-evident, irrefutable, in reality. You can't make them not that.
I've still got this sticker. Don't talk of the not that. Because it's a nonsense. This is how magic's performed. The moment that you speak a nonsense, people don't have the ability to process it. Our brains are set up to process logical information and put it in those brackets. But if you give somebody a nonsense, then their brains don't know how to process it. And I believe that the education system has prepared the brains to have a filing cabinet to be able to place that nonsense in a certain cupboard and do something with it. Whereas there are certain people that are out there that brain just can't process it, so it just passes you by. I think that's how I think the women are like that. I think that a woman's brain has a better ability than a man's brain to deal with nonsense in the way that it just disregards it. The male brain likes to solve problems. And if you're given a nonsense, how do you process it? Your brain's not set up to be able to do it. That's magic.
Yeah. I was explaining some of that stuff today, talking about it in the car as we were driving, and my missus kind of looks at me and in that way that what the hell you know, it's rubbish.
I don't
What
even know
what
why
you
you're
even bother with
bothering
that?
with it. Yeah,
Yeah,
don't
and it
know.
kind of makes and it kind of makes you feel like, oh God, I'm wasting my time here. I should be doing the garden or painting the room or something. I'm wasting my time. But it's something that's kind of addictive in some sense. But this kind of quest for the truth of this and to logically work through this is maybe more of a man thing than a woman thing. But
It's like
we've
a
never.
certain type of person, right? 'Cause once
Yeah,
you get on this thing, you get into it deep. Certain people do, right? Certain
yeah.
people get into this that deep that sometimes you can be in it for years and not realize, and then realize how it's affected you. In the way that you talk to people and you discuss certain things. And I don't know, like, you do notice it once you've been around for a while, that the same people are still around here doing the same
Yeah, I
thing. And a
mean,
lot of people say the same thing about us, that we're doing the same thing, and they might be right.
yeah, I mean, when visiting family today, and the conversation got to this eventually. It didn't start out like that. My brother-in-law, does lighting, and he does some of these big shows. They're all over the world. And there's one called Traitors. He does Love Island. He does Celebrity Get Me Out of Here, that kind of thing, right? And we were talking about there's a game show called The Traitors, and it's a very psychological thing. It's a bit of a reality thing, but I said, "Oh wow!" I said, because I said I've seen some of that. And I'm really interested in the psychology of people as they go through this process, And he was telling me about the behind the scenes stuff, where the production team are getting information out of some of these people there, and then guiding the narrative of the story, and mentioning something to one of the other people, some information about these other people to guide and steer the whole narrative of the story. And then they've got psychologists to sort these people heads out at the end, after they've messed them up and dangled $100,000 in them, which they've got to cheat somebody else out of.
Yeah.
Somebody's got to pretend they're a traitor and lie to all these people in order to get this money. And then the people at the end, who are the last one I saw, this woman, she was tight with this guy and believed that they were there's the faithful or the traitors. They were faithful. She was tight with this guy. And when they got to the end, there was one guy who was the traitor, and she went with this other guy, and she dumped the guy she'd been with, and she was devastated when she realized that she'd been conned. I mean, she was really, really upset that and this other guy who'd won, he was obviously upset about it too. But then when they got rid of her and said, "Well, you've won, here's the money," and got the champagne out, he then, the greed took over or whatever. But you're just thinking about the psychology of how that works. And I said, it's funny because that's going on in politics. It's going on in the world. It's going on in this arena we're hearing now. The psychology and the playing of games with people's minds to steer a narrative, and then talking with my other relative who's a plumber, and talking about the taxation that's being put on gas boilers to drive people away from having gas boilers because they're told that that's a bad thing to have, and the environment and all that, and how it's all linked to this new tax, this carbon tax. And then we got onto this, onto what and what you don't know, and what's happening in the, how psychology is being used in all sorts of areas to steer the minds and the thoughts of people. And we finally got to water level. And so it's I thought on the way, I mustn't talk about any of this stuff. I've got to try and not talk about this, just talk about the kids and how's the garden and where have you been. But eventually it got round to this question, and it was interesting watching that. But they were a bit more open, because we'd had this talk about how psychology is being used on the children in gaming and education. So it's all around. It's not, and I said, yeah, this is a bit of a weird arena, but the same things are happening here. This is happening out in the world.
Yeah, it gives you a
People are
chance
being
to make
manipulated.
an analogy
Yes.
that's relatable, right?
Yeah.
You can,
Yeah.
the better picture you can paint with your words,
Yeah.
the more understandable it'll be, and the more
Yeah.
people will reciprocate with the conversation.
Yeah, so this may be a bit of a niche arena to the whole population. I still think there's a lot of people involved in it. It's not 25% of the population or anything. It's not big in that sense. But what's going on here and what I see going on is what's happening in the rest of the world with a different narrative, a different set of terms. But this psychological thing. So this kind of crossover from Euclidean to non-Euclidean, binary to non-binary, gender stuff. This crossover where what was deemed to be real is not real anymore. The narratives being presented in people's heads before they have any experience, so they just believe in and thinking X when it's actually Y. That they're convinced, told it's X, it's X, and then they're convinced to be that, and then maybe later on they say, but actually it's actually Y. We didn't. Yeah. So there's a mirror of all those things happening here in this thing, and that interests me, I must say. This psychology and that's why I had expected that there would be some simple explanation for this crossover from Euclidean to non-Euclidean. I would have thought there would have been a very simple, shortest distance from A to B is a straight line.
Right, the idea of once you take it on, the Euclidean proofs are something that like you take to your mind, and it's the way that you perceive reality to be. You relate reality to this sort of gaining of knowledge and understanding of how to relate things to each other. Well, it sort of shows you what's happened to this relativity, right? Because that's literally what it is. It's a big trick to play with your mind to get you to bend this. It's the bending of the mind.
Yeah. Mm.
In that sense, it's much bigger. Because I always thought, right, that because of I have this thing that I don't dream. So I always, for me to relate that to, was to something to say that if you had a dream, then it was because something wasn't quite right. Right? Your brain was telling you you need to fix this. But because your brain relates to you in these dream sense, it's trying to tell you a message, but it's whether you interpret it and get the message from whatever the dream is. That's why a lot of people like to express their dreams to other people, because they're obviously trying to sort something out. Well, I don't dream, so I related that to the fact that, I'm okay. I don't need to. My brain just tells me, like, you don't need to sort anything out. But in the way of this, that in order for you to deal with reality, a lot of people turn to drugs or alcohol. There's different things because I believe it's because they find it difficult to relate to reality because they've already been given a contradiction. And they're holding contradictions, and that way it makes it even harder to relate to reality because you're already holding these contradictions. And what we've got here is a way to rid yourselves of this with epohe.
And that does free up a lot of this confusion. For me,
yeah,
anyway.
and that can only be good. That can only be a good thing, though,
Yeah.
isn't it? You know, that's what I think of these people saying this is negative and brainwashing and all that. I don't experience that at all. I experience more light, more focus, more clarity about some things, you know. And they don't all come from words that are said here. They come from the thoughts afterwards, or something deeper, something, you know.
Yeah,
You're
you get
just moving
something
along.
to take away for yourself, right? There's a lot of moments of silence where you're contemplating things. And that's good.
Yeah.
In saying that, I'm going to have to end this tonight.
Yep. Thank you.
It's Free for All Friday tomorrow, so we will be out for a proper free for all. Hope that people will be able to come, and then I think on Sunday we're going to have a good riddance to 2023, and we'll just have a recap, and everybody can maybe have a drink or whatever and go over it. For the people that are sad and lonely at home, we'll just have a pub evening where everybody can come in and have a chat, maybe all day, who knows. New Year's Eve. Yeah, so that's what we're going to be doing. Free for All Friday tomorrow, and then some sort of a good riddance New Year's bash. Okay, let me get a Buster song.
I know, I got it. I got it.
Whoa.
We gotta keep this train going. I'm off, so I'm trying to take advantage of it.
Buster.
Are you ready?
Yeah.
That's it. Yes, rolling out. I think this is fitting. Maybe somebody will get something out of it. All right, here we go.
I see the writing on the wall, it's plain. The ramblings of these madmen going insane. And now I see it clear. They're running and they're hiding because of fear. Transcendental numbers and conceptual maths will take you on a journey down a Penrose path, and you'll never see it clear, 'cause the path that they're on only ends in tears. If I don't sing and if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will? Cast away the shadows and step into light. Wait, taking down the giants and open inside. And now I see it clear, the path that they're on because of fear. If I don't sing and if I don't speak out, if I never communicate with logic, who will? If I don't sing and if I don't speak out, if I never receive the Logos, who will? taking back everything that was lost. I'll take it back at any cost. And I'm taking back everything that was lost. I'll take it back at any cost. And I'm taking back everything that was lost. And I'll take it back at any cost. If I don't sing, if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will?